KS, Registrar, University of Mysore, Professor H.T. Basavarajappa, Dean, Faculty of Science and Technology, University of Mysore. Ellarigu namaskara. Good morning to you all. As you all know, the National Science Day is celebrated to commemorate the discovery of Raman effect by Nobel laureate physicist Sir C.V. Raman on this day in 1928. In 1986, the National Council for Science and Technology asked the Government of India to designate February 28th as National Science Day. Since 1987, the event is now celebrated all over the country in schools, colleges, universities, and other academic, scientific, technical, medical, and research institutions. The celebration also includes public speeches, radio, TV, science movies, science exhibitions, debates, and many more activities. Chandrasekhar Venkataraman was a physicist. His work in the field of light scattering earned him the Nobel Prize in 1930. This phenomenon was known as Raman effect. Raman was the first Asian to receive a Nobel Prize in any branch of science. In 1954, he was honored with India's highest civilian award, the Bharat Ratna, which was the first Bharat Ratna by the Government of India. Themes were given to National Science Day since 1999. To recall some of them, 1999, Our Changing Earth, 2002, Wealth from Waste, 2005, Celebrating Physics, 2007, More Crop Per Drop, 2009, Expanding Horizons of Science, 2011, Chemistry in Daily Life, 2015, Science for Nation Building, 2019, Science for People and People for Science. 2023, that is this year, the theme of the National Science Day is Global Science for Global Well-Being. We may also recall some of the prestigious awards won by Sir C.V. Raman, Fellow of the Royal Society 1924, Matency Medal 1928, Knight Bachelor 1930, Hughes Medal 1930, Nobel Prize 1930. Bharat Ratna 1954, Lenin Peace Prize 1957. Sir C.V. Raman was born on 7th November 1888 and left his mortal coil on 21st November 1970. He served humanity through the channel of science to the best of his ability and earned our eternal gratitude in the process. Without much ado, I call upon Raghu R., the faculty member of Fine Arts College, University of Mysore, to present us the invocation.
Namaste, Govinda. Tatvartha Samyapaka Tatvartha Samyapaka Vinayaka Tatvartha Samyapaka Vinayaka Satvokti Chinmatrika Shivaitya Tatvartha Samyapaka Vinayaka Tatvokti Chinmatrika Shivaitya Tatvartha Samyapaka Ramaniya Gajavadana Smaraniya ಗುಣಸದನ ರಮಣೀಯ ಗಜವದನ ಸ್ಮರಣೀಯ ಗುಣಸದನ ನಮಿತಾನುಕಂಪನ ಘನವಾಮನ ನಮಿತಾನುಕಂಪನ ಘನವಾಮನ ವಿಮಲೋದರೌದಾರ್ಯ ಕ್ರಮಜಾಗೃದಾರ್ಯ ವಿಮಲೋದರೌದಾರ್ಯ ಕ್ರಮಜಾಗೃದಾರ್ಯ ಸುಮಸಾಯ ಕಾತಿ ಜಿತ ಚೇತನ ಗಾಮದ ಮಗರಿ ಸದ ಸರಿ ಗ ಮದ ಸನಿದ ಮಗರಿ ಸ ಗಾಮದ ಮಗರಿ ಸದ ಸರಿ ಗ ಮದರಿ ನಿದ ಮಗರಿ ಸ ರಿ ಗಮದ ಗಮದ ಸಾಸ ಮದ ಸರೀರಿ ಸನಿದ ಮಗರಿ ಸರಿ ಗಮದ ಗಮದ ಸ ಮದ ಸರಿರಿ ಸನಿದ ಮಗರಿ ಸ ಮಗಮ ಪದ ನಿದ ಮಗರಿ ಸ ಗದ ಮದ ಸನಿದ ಮದ ಸರಿ ನಿದ ಮಗ ಮದರಿ ನಿದ ಮಗ ಮದ ಸರಿ ಗರಿ ಸ ಗರಿ ಸ ನಿದ ರಿ ಸ ಗರಿ ಸ ನಿದ ಸ ಗರಿ ಸ ನಿದ ರಿ ಸ ರಿ ಸ ನಿದ ಮಪ ಮಗ ಮಗರಿ ಸದತ ತ್ವಾರ್ಥ ಸಂಜ್ಞಾಪಕ ಆದಿಮಾಶ್ರಮಾದಿಮೂಲಮೋಹನ ವೇದ ವ್ಯಾಸವಾದ್ವಿಲಾಸಲೇಖನ ಮೇಧೋ ಮೇಧುರ ಬಂಧುರ ಮೇಧೋಚ್ಛೇದನ ಸುಂದರ ಮೇಧೋ ಮೇಧುರ ಬಂಧುರ ಮೇಧೋಚ್ಛೇದನ ಸುಂದರ ಸದಾಶಿವ ಮುದಾಹವ ಸುಧಾಕರ ಸುಧಾಹರ ಸದಾಶಿವ ಮುದಾಹವ ಸುಧಾಕರ ಸುಧಾಹರ ತೋಯಿನ ಗಾನ ಶಿಖರ ಸುತ ವಿಹಿತ ಮಹಿತ ವರ ಸುತ ಗಾಮದ ಮಗರಿ ಸದ ಸರಿ ಗ ಮದ ಸನಿದ ಮಗರಿ ಸ ರಿ ಗಮದ ಗಮದ ಸಾಸ ಮದ ಸರೀರಿ ಸನಿದ ಮಗರಿ ಸ ಮಗಮ ಪದ ನಿದ ಮಗರಿ ಸ ಗದ ಮದ ಸನಿದ ಮದ ಸರಿ ನಿದ ಪಗ ಮದರಿ ನಿದ ಮಗ ಮದ ಸರಿ ಗರಿ ಸ ಗರಿ ಸ ನಿದ ರಿ ಸ ಗರಿ ಸ ನಿದ ಸ ಗರಿ ಸ ನಿದ ರಿ ಸ ನಿದ ಮಗ ಮಗ ಮಗರಿ ಸದತ ಸ್ವಾರ್ಥ ಸಂಜ್ಞಾಪಕ ವಿನಾಯಕ
Thank you, Sri Raghu. Once again, kindly come to the mic and sing the state anthem Nadagite. And as Raghu sings the Nadagite, all of us will keep standing.
जय भारत जननीय तनुजाते जय हे कर्नाटक माते जय सुंदर नदिवनಗಳ ನಾಡೆ जय हे रस ಋಷಿಗಳ ಬೀಡೆ ಭೂದೇವಿಯ ಮಕುಟದ ನವಮಣಿಯೇ ಗಂಧದ ಚಂದದ ಹೊನ್ನಿನ ಗಣಿಯೇ ರಾಘವ ಮಧುಸೂದನರವತರಿಸಿದ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜನನಿಯ ಜೋಗುಳ ವೇದದ ಘೋಷ ಜನನಿಗೆ ಜೀವವು ನಿನ್ನಾವೇಶ ಹಸುರಿನ ಗಿರಿಗಳ ಸಾಲೆ ನಿನ್ನಯ ಕೊರಳಿನ ಮಾಲೆ ಕಪಿಲ ಪತಂಜಲ ಗೌತಮ ಜಿನನುತ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಶಂಕರ ರಾಮನುಜ ವಿದ್ಯಾರಣ್ಯ ಬಸವೇಶ್ವರ ಮಧ್ವರ ದಿವ್ಯಾರಣ್ಯ ರನ್ನ ಷಡ ಶರಿ ಪೊನ್ನ ಪಂಪಲ ಕುಣಿಪತಿ ಜನ್ನ ಕುಮಾರ ವ್ಯಾಸರ ಮಂಗಳಧಾಮ ಕವಿ ಕೋಗಿಲೆಗಳ ಪುಣ್ಯಾರಾಮ ನಾನಕರಮಾನಂದ ಕಬೀರರ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ತೈಲಪ ಹೊಯ್ಸಳರಾಳಿದ ನಾಡೆ ಡಂಕಣ ಜಕಣರ ನೆಚ್ಚಿನ ಬೀಡೆ ಕೃಷ್ಣ ಶರಾವತಿ ತುಂಗ ಕಾವೇರಿಯವರ ರಂಗ ಚೈತನ್ಯ ಪರಮಹಂಸ ವಿವೇಕರ್ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಸರ್ವ ಜನಾಂಗದ ಶಾಂತಿಯ ತೋಟ ರಸಿಕರ ಕಂಗಳ ಸೆಳೆಯುವ ನೋಟ ಹಿಂದೂ ಕ್ರೈಸ್ತ ಮುಸಲ್ಮಾನ ಪಾರಸಿಕ ಜೈನರುದ್ಯಾನ ಜನಕನ ಹೋಲುವ ದೊರೆಗಳ ಧಾಮ ಗಾಯಕ ವೈಣಿಕರಾರಾಮ ಕನ್ನಡ ನುಡಿ ಕುಣಿದಾಡುವ ದೇಹ ಕನ್ನಡ ತಾಯಿಯ ಮಕ್ಕಳ ದೇಹ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ.
Thank you, Raghu, for the soulful rendering of both invocation and the state anthem. Now I request the dignitaries on the dais to light the lamp and inaugurate the proceedings. Thank you, sirs and madam. Professor Gnana Prakash, the registrar evaluation of our university, is from the physics stream. He is a postdoctoral fellow, School of Electrical and Computer Engineering, Georgia Institute of Technology, Atlanta, USA. And he is also a postdoctoral fellow, Department of Physics, National Donghua University, Hualien, Taiwan, Republic of China. Published 120 papers in reputed international journals, has presented 152 papers in national and international conferences. Professor Gnana Prakash has published a book in 2016 titled Application of Pelletron Accelerator to Study Total Dose Radiation effects on MOS and bipolar devices. Now I request our Honorable Registrar Evaluation, Professor Gnan Prakash, to welcome the guests in the gathering and also to present us the opening remarks.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಮೊದಲಿಗೆ ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನಾಚರಣೆಯ ಶುಭಕಾಮನೆಗಳು. ವೇದಿಕೆಯ ಮೇಲೆ ಆಸೀನರಾಗಿರುವ ನವದೆಹಲಿಯ ಅಖಿಲ ಭಾರತೀಯ ವೈದ್ಯಕೀಯ ವಿಜ್ಞಾನ ಸಂಸ್ಥೆ ಜೀವ ಭೌತಶಾಸ್ತ್ರ ವಿಭಾಗದ ಗೌರವಾನ್ವಿತ ಜೈವಿಕ ತಂತ್ರಜ್ಞಾನ ಸಂಶೋಧನಾ ಪ್ರಾಧ್ಯಾಪಕರಾದ ಪ್ರೊಫೆಸರ್ TP ಸಿಂಗ್ ಅವರೇ, ಇಂದಿನ ಕಾರ್ಯಕ್ರಮದ ವಿಶೇಷ ಉಪನ್ಯಾಸವನ್ನು ನೀಡಲು ಆಗಮಿಸಿರುವಂತಹ ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾಲಯದ ವಿಶ್ರಾಂತ ಕುಲಪತಿಗಳಾದ ಪ್ರೊಫೆಸರ್ SN ಹೆಗ್ಡೆರ್ ಅವರೇ, ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾಲಯದ ಕುಲಪತಿಗಳಾದ ಪ್ರೊಫೆಸರ್ ಮುಜಾಫರ್ ಅಸಾದಿ ಅವರೇ, ಕುಲಸಚಿವರಾದ ಶ್ರೀಮತಿ ಶೈಲಜರ್ ಅವರೇ, ಹಣಕಾಸು ಅಧಿಕಾರಿಗಳಾದ ಶ್ರೀಮತಿ ಸಂಗೀತಾ ಗಜಾನನ ಭಟ್ರವರೇ, ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ನಿಕಾಯದ ಡೀನ್ ರವರಾದ ಪ್ರೊಫೆಸರ್ HT ಬಸವರಾಜಪ್ಪನವರೇ, ವಿಶ್ರಾಂತ ಕುಲಪತಿಗಳಾದ ಪ್ರೊಫೆಸರ್ KS ರಂಗಪ್ಪನವರೇ, ಸಿಂಡಿಕೇಟ್ ಹಾಗೂ ಶೈಕ್ಷಣಿಕ ಮಂಡಳಿಯ ಸದಸ್ಯರೇ, ಎಲ್ಲಾ ನಿಕಾಯದ ಡೀನ್ಗಳವರೇ, ಸಹೋದ್ಯೋಗಿ ಮಿತ್ರರೇ, ಆಹ್ವಾನಿತರೇ, ಸಂಶೋಧಕರುಗಳೇ, ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಅಧ್ಯಾಪಕ ಮತ್ತು ಅಧ್ಯಾಪಕೇತರ ವೃಂದದವರೇ ಹಾಗೂ ಮಾಧ್ಯಮ ಮಿತ್ರರೇ, ಸ್ನೇಹಿತರೆ. ನಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ, ರವಿ ಕಾಣದ್ದನ್ನು ಕವಿ ಕಂಡ, ಅದು ಕವಿಗಿರುವ ಶಕ್ತಿ. ಆದರೆ ಕವಿ ಕಾಣದ ಪದಗಳಿಗೆ ನಿಲುಕದ ಸಹಸ್ರ ಸಂಗತಿಗಳು ನಮ್ಮೆದುರಿಗೆ ಓಡಾಡಿಕೊಂಡಿವೆ. ಯಾರಿಗೂ ಕಾಣುವುದಿಲ್ಲ. ಅಷ್ಟೇ ಅವನ್ನು ಕಾಣಲು ಬರಿಗಣ್ಣು ಅಷ್ಟೇ ಸಾಲದು, ವೈಜ್ಞಾನಿಕ ವೈಚಾರಿಕ ದೃಷ್ಟಿ ಮನಸ್ಸುಗಳು ಬೇಕು. ಹಾಗಾಗಿ ರವಿ ಕಾಣದ್ದನ್ನು ಕವಿ ಕಂಡ, ಕವಿ ಕಾಣದ್ದನ್ನು ವಿಜ್ಞಾನಿ ಕಂಡ ಅಂದರೆ ಅಕ್ಷರಃ ತಪ್ಪಾಗುವುದಿಲ್ಲ. ಬೆಳಗಿನ ಸೂರ್ಯೋದಯ, ಹಾಲಿನ ನೊರೆ ಉಪ್ಪಿಸುವ ಜಲಪಾತ, ನಿರಭ್ರ ನೀಲಾಕಾಶ, ನೀಲುಯುಕ್ಕುವ ಕಡಲು, ಬಿಸಿಲು ಮಳೆಯ ಕಾಮನ ಬಿಲ್ಲು, ಸೂರ್ಯಾಸ್ತದ ಸಂಜೆಯ ಸೊಬಗು, ಇವುಗಳನ್ನು ಕಂಡಾಗ ಎಂತಹ ಅರಸಿಕನೋ ಅರೆಕ್ಷಣ ಮೈಮರೆಯುತ್ತಾನೆ. ಜ್ಞಾನ ಮನಸ್ಸು ಮುದುಗೊಳ್ಳುತ್ತದೆ, ಪದಗಳು ಕವಿತೆಯ ಸಾಲಾಗುತ್ತವೆ. ಹೆಚ್ಚಿನವರು ನೀವು ಏಕೆ ಹೀಗೆ ಎಂದು ಪ್ರಶ್ನಿಸಿಕೊಳ್ಳುವುದಿಲ್ಲ. ಅದರ ಹಿಂದೆ ಇರುವ ವೈಜ್ಞಾನಿಕ ಚಮತ್ಕಾರದ ಬಗ್ಗೆ ತಲೆ ಕೆಡಿಸಿಕೊಳ್ಳುವುದಿಲ್ಲ. ಸೃಷ್ಟಿಯ ಅದ್ಭುತವನ್ನು ಹಾಗೆ ಕಣ್ಣು ತುಂಬಿಕೊಂಡು ಸುಮ್ಮನಾಗುತ್ತಾರೆ. ಆದರೆ ಬೆಳಕು ಬರೀ ಬೆರಗು ಮೂಡಿಸುವ ಸಂಗತಿಯಲ್ಲ, ಅದೊಂದು ವಿದ್ಯಮಾನ ಎಂದರೆ ನೀವು ನಂಬಲೇಬೇಕು. ಬೆಳಕೆಂಬ ಬೆಳಕಿನ ಬೆನ್ನು ಬಿದ್ದವರೆಷ್ಟೋ, ಬೆಳಕಿನ ಅಂತರಂಗವನ್ನು ಭೇದಿಸಲು ಪ್ರಯತ್ನ ಪಟ್ಟವರೆಷ್ಟೋ, ಹಾಗೆ ಕೌಶಿಕನ ತಪಸ್ಸಿನಂತೆ ವರ್ಷಗಟ್ಟಲೆ ಬೆಳಕನ್ನೇ ಧ್ಯಾನಿಸಿ ಬೆಳಕಿನ ಅಂತರಂಗಕ್ಕೆ ದಿರ್ಬುಯಿನನ್ನು ಹಾಕಿ ಬೆಳಕಿನ ಮೇಲೆಯೇ ಬೆಳಕು ಚೆಲ್ಲಿ ಯಶಸ್ವಿಯಾದ ವಿಜ್ಞಾನಿಗಳು ಮಾತ್ರ ಬೆರಳೆಣಿಕೆಯಷ್ಟು. ಅಂತಹ ಮಹನೀಯರಲ್ಲಿ ಸರ್ CV ರಾಮನ್ ಒಬ್ಬರು. ಅದು 1921 ಸಮಯ. ಸರ್ CV ರಾಮನ್ ಅವರು ಪ್ರತಿಷ್ಠಿತ ವಿಜ್ಞಾನ ಸಮ್ಮೇಳನವೊಂದರಲ್ಲಿ ಭಾಗವಹಿಸಿ ಲಂಡನ್ನಿನಿಂದ ಭಾರತಕ್ಕೆ ವಾಪಸ್ ಆಗುತ್ತಿದ್ದರು. ಅದು ಹಡಗಿನ ಸುದೀರ್ಘ ಪಯಣ. ತಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ, ಸುಮಾರು 2-3 ತಿಂಗಳ ಪಯಣ. ಎಲ್ಲೆಲ್ಲೂ ನೀರು. ರಾಮನ್ ಅವರು ಸಾಗರದ ಶುಭ್ರ ನೀಲಿ ಬಣ್ಣವನ್ನು ಕಂಡು ವಿಸ್ಮಯಗೊಳ್ಳುತ್ತಾರೆ. ಕೂಡಲೇ ಅವರೊಳಗಿದ್ದ ವಿಜ್ಞಾನಿ ಜಾಗೃತಗೊಳ್ಳುತ್ತಾನೆ. ಸಾಗರದ ನೀರನ್ನು ಪಾತ್ರೆಗಳಲ್ಲಿ ತುಂಬಿಸಿ ತಮ್ಮ ಬಳಿ ಇದ್ದ ರೋಹಿತ ದರ್ಶಕ ಅಂದ್ರೆ ಸ್ಪೆಕ್ಟ್ರೋಮೀಟರ್ ಅನ್ನು ಬಳಸಿಕೊಂಡು ಹಡಗಿನಲ್ಲಿಯೇ ಪ್ರಯೋಗ ಆರಂಭಿಸುತ್ತಾರೆ. ಸೂರ್ಯನ ಬೆಳಕು ಹಲವು ಬಣ್ಣಗಳಿದ್ದು ವಿವಿಧ ತರಂಗಾಂತರಗಳಿಂದ ಮಾಡಲ್ಪಟ್ಟಿದೆ. ಸೂರ್ಯನ ಬೆಳಕು ಸಮುದ್ರಕ್ಕೆ ಅಪ್ಪಳಿಸಿದಾಗ ನೀರಿನ ಕಣಗಳು ಹೆಚ್ಚಿನ ತರಂಗ ದೂರವಿರುವ ಬೆಳಕನ್ನು ಹೀರಿಕೊಳ್ಳುತ್ತವೆ, ಕಡಿಮೆ ತರಂಗ ದೂರವಿರುವ ನೀಲಿ ಬೆಳಕನ್ನು ಚದುರಿಸುತ್ತವೆ. ಹೀಗೆ ಸಾಗರದ ನೀಲಿಯ ಹಿಂದೆ ಅವಿತುಕೊಂಡಿದ್ದ ನಿಗೂಢತೆಯನ್ನು ರಾಮನ್ ಅವರು ಬಯಲಿಗೆಳೆಯುತ್ತಾರೆ. ತಮ್ಮ ಸಂಶೋಧನಾ ಬರಹವನ್ನು ಲಂಡನ್ನ ನೇಚರ್ ಪತ್ರಿಕೆಗೆ ಕಳಿಸುತ್ತಾರೆ. ಅದು ಪ್ರಕಟಗೊಂಡು ವಿಶ್ವದ ವಿಜ್ಞಾನಿಗಳ ಗಮನವನ್ನು ಸೆಳೆಯುತ್ತದೆ. ಹೀಗೆ ಬೆಳಕಿಗೆ ಬಂದ ಪ್ರಾಥಮಿಕ ಆವಿಷ್ಕಾರ ರಾಮನ್ ಅವರನ್ನು ಬೆಳಕಿನ ಚದುರಿಕೆಯ ಮೇಲೆ ಇನ್ನಷ್ಟು ಸಂಶೋಧನೆ ಕೈಗೊಳ್ಳಲು ಪ್ರೇರೇಪಿಸುತ್ತದೆ. ಆ ಪ್ರೇರಣೆಯ ಕಿಡಿ ಅದೆಷ್ಟು ತೀವ್ರವಾಗಿತ್ತು ಎಂದರೆ, ಸುಮಾರು 7 ವರ್ಷಗಳ ನಿರಂತರ ಪ್ರಯತ್ನದ ಫಲವಾಗಿ 1928 ಫೆಬ್ರವರಿ 28ರಂದು ರಾಮನ್ ರವರಿಗೆ ಮಹತ್ವದ ಸಂಶೋಧನೆಯ ಸಾಕ್ಷಾತ್ಕಾರವಾಗುತ್ತದೆ. ಅಂದು ರಾಮನ್ ಅವರು ರಾಮನ್ ಪರಿಣಾಮವನ್ನು ಪ್ರಾಯೋಗಿಕವಾಗಿ ನಿರೂಪಿಸಿದರು. ಇದಾದ 2 ವರ್ಷಗಳಲ್ಲಿ ನೊಬೆಲ್ ಬಹುಮಾನವು ಅರಸಿ ಬಂತು. 1930 ಡಿಸೆಂಬರ್ 11ರಂದು ಸ್ಟಾಕ್ಹೋಮ್ನಲ್ಲಿ ಕಿಕ್ಕಿರಿದ ಸಭಾಂಗಣದಲ್ಲಿ ನೆರೆದಿದ್ದ ಅನೇಕ ಪಾಶ್ಚಾತ್ಯ ವಿಜ್ಞಾನಿಗಳ ಸಮ್ಮುಖದಲ್ಲಿ ರಾಮನ್ ಅವರು ಭಾರತೀಯ ಉಡುಪು ಧರಿಸಿ ನೊಬೆಲ್ ಬಹುಮಾನವನ್ನು ಸ್ವೀಕರಿಸಿದರು. ತಮ್ಮ ಆವಿಷ್ಕಾರದಲ್ಲಿ ಸಹಾಯಕರಾಗಿದ್ದ ಕೃಷ್ಣನ್ ರವರ ಕೊಡುಗೆಯನ್ನು ರಾಮನ್ ಮರೆಯದೆ ಸ್ಮರಿಸಿಕೊಳ್ಳುತ್ತಾರೆ. ರಾಮನ್ ಅವರಿಗೆ ತಮ್ಮ ಆವಿಷ್ಕಾರದ ಬಗ್ಗೆ ಎಷ್ಟು ಅವರಿಗೆ ಕಾನ್ಫಿಡೆನ್ಸ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, 1929ಕ್ಕೆ ಅವರು ನನಗೆ ನೊಬೆಲ್ ಪಾರಿತೋಷಿಕ ಸಿಗುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಅವರು ರೆಡಿ ಆಗಿದ್ರಂತೆ. ಬಟ್ 1920ಕ್ಕೆ ಕಾಂಪ್ಟನ್ಗೆ ಅದು ಬಂತು, ಕಾಂಪ್ಟನ್ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಆಗಿ. ಸೊ ದಿಸ್ ಇಸ್ ಅ ಲೈಟ್ ಸ್ಕ್ಯಾಟರಿಂಗ್, ದಟ್ ಈಸ್ ಅನ್ ಎಕ್ಸ್ರೇ ಸ್ಕ್ಯಾಟರಿಂಗ್. ನಮ್ಮ ಫಿಸಿಕ್ಸ್ ಕೆಮಿಸ್ಟ್ರಿ ಅವರಿಗೆಲ್ಲ ಗೊತ್ತಿದೆ. 1929ಕ್ಕೆ ಕಾಂಪ್ಟನ್ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಬಗ್ಗೆ ಬಂತು. 1930ಕ್ಕೆ ರಾಮನ್ ಅವರಿಗೆ ಲೈಟ್ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಮೇಲೆ ಅವರಿಗೆ ನೊಬೆಲ್ ಪಾರಿತೋಷಿಕ ಬಂತು. 1921ರಿಂದ ಕೋಲ್ಕತ್ತಾದಲ್ಲಿ ಬೆಳಕಿನ ಚೆದುರುವಿಕೆಯ ಬಗ್ಗೆ ನಡೆಸಿದ ಸಂಶೋಧನೆಯ ಬದಲಿಗೆ 1928ರ ಸಂಶೋಧನೆಯನ್ನು ಗಮನದಲ್ಲಿಟ್ಟುಕೊಂಡು ನೊಬೆಲ್ ಬಹುಮಾನವನ್ನು ನೀಡಲಾಗಿದೆ. ಕೃಷ್ಣನ್ ಅವರಿಗೂ ಅವರ ಸ್ಟೂಡೆಂಟ್ ಕೃಷ್ಣನ್ ಅವರಿಗೂ ಇದು ಅರ್ಹವಾಗಿಯೇ ಸಲ್ಲಬೇಕು ಎಂದು ಹಲವು ಬಾರಿ ರಾಮನ್ ಅವರು ಹೇಳುತ್ತಾರೆ. ಹಾಗಾದರೆ ಏನಿದು ರಾಮನ್ ಪರಿಣಾಮ? ಸೊ ವಾಟ್ ಈಸ್ ದ ರಾಮನ್ ಎಫೆಕ್ಟ್? ಸರಳವಾಗಿ ಹೇಳುವುದಾದರೆ ರಾಮನ್ ಪರಿಣಾಮ ಎನ್ನುವುದು ಬೆಳಕಿನ ಚೆದುರುವಿಕೆಯ ಒಂದು ವಿದ್ಯಮಾನ. ಸ್ವಲ್ಪ ವಿವರಿಸಿ ಹೇಳುವುದಾದರೆ, ಪಾರದರ್ಶಕವಾದ ಯಾವುದೇ ಒಂದು ವಸ್ತು, ಅದು ಘನ, ದ್ರವ ಅಥವಾ ಅನಿಲ, ಯಾವುದೇ ರೂಪದಲ್ಲಿರಲಿ, ಅದರ ಮೂಲಕ ಪ್ರಖರವಾದ ಬೆಳಕನ್ನು ಹಾಯಿಸಿದಾಗ ಅದರಿಂದ ಹೊರಬರುವ ಕಿರಣಗಳು ಮೂಲ ಕಿರಣಗಳಿಗಿಂತ ಭಿನ್ನವಾದ ದಿಕ್ಕಿನತ್ತ ಹೊರಳುವುದನ್ನು ನಾವು ಗಮನಿಸಬಹುದು. ಹೀಗೆ ಚೆದುರಿರುವ ಬಹುಪಾಲು ಕಿರಣಗಳ ಸ್ವರೂಪ ಮೂಲ ಕಿರಣದಂತೆಯೇ ಇರುತ್ತದೆ, ಆದರೆ ಒಂದಷ್ಟು ಕಿರಣಗಳ ತರಂಗಾಂತರ ಮೂಲಕ್ಕಿಂತ ವಿಭಿನ್ನವಾಗಿರುತ್ತದೆ. ರಾಮನ್ ಅವರು ಇಲ್ಲಿ ಕ್ವಾಂಟಮ್ ಸಿದ್ಧಾಂತವನ್ನು ಬಳಸಿಕೊಳ್ತಾರೆ. ಬೆಳಕಿನ ಕಿರಣ ಅಸಂಖ್ಯಾತ ಶಕ್ತಿಯ ಫೋಟಾನ್ಗಳ ಪ್ರವಾಹ ಎನ್ನುತ್ತದೆ ಕ್ವಾಂಟಮ್ ಸಿದ್ಧಾಂತ. ಈ ಬೆಳಕಿನ ಫೋಟಾನ್ಗಳು ಮತ್ತು ಮಾಧ್ಯಮದ ಅಣುಗಳು ಒಂದಕ್ಕೊಂದು ಡಿಕ್ಕಿ ಹೊಡೆಯುತ್ತವೆ. ಅವುಗಳ ಅತ್ಯಲ್ಪ ಭಾಗ ಮಾತ್ರ ತರಂಗಾಂತರಗಳಲ್ಲಿ ಬದಲಾವಣೆಯಾಗಿ ಬಣ್ಣವು ಬದಲಾಗುತ್ತದೆ. ಹೀಗೆ ಡಿಕ್ಕಿ ಹೊಡೆದು ಚದುರಿದ ಬೆಳಕಿನ ಕಣಗಳು ಅಥವಾ ಫೋಟಾನುಗಳ ಪೈಕಿ ಮಿಲಿಯನ್ನ ಒಂದು ಭಾಗ ಮಾತ್ರ ರಾಮನ್ ಪರಿಣಾಮಕ್ಕೆ ಒಳಗಾಗುತ್ತವೆ. ಪರಿಣಾಮವಾಗಿ ಮೂಲ ರೋಹಿತ ರೇಖೆಯ ಇಕ್ಕೆಲದಲ್ಲಿ ಹೊಸ ರೇಖೆಗಳು ಪ್ರಕಟಗೊಳ್ಳುತ್ತವೆ. ಇವೇ ರಾಮನ್ ರೇಖೆಗಳು. ಸೊ ಫಿಸಿಕ್ಸ್ ಕೆಮಿಸ್ಟ್ರಿ ಅವರಿಗೆ ಗೊತ್ತಿದೆ, ರ್ಯಾಲೀಸ್ ಲೈನ್ಸ್, ಸ್ಟೋಕ್ಸ್ ಲೈನ್ಸ್ ಅಂಡ್ ಆಂಟಿ ಸ್ಟೋಕ್ಸ್ ಲೈನ್ಸ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಈ ವಿದ್ಯಮಾನವೇ ರಾಮನ್ ಪರಿಣಾಮ ಅಥವಾ ರಾಮನ್ ಎಫೆಕ್ಟ್ ಅಂತ ಹೇಳಿ ನಾವು ಕರಿತೀವಿ. ರಾಮನ್ ರೇಖೆಗಳು ಬರಿಗಣ್ಣಿಗೆ ಕಾಣುವುದಿಲ್ಲ. ಹಾಗಾಗಿ ರಾಮನ್ ಅವರೇ ಆವಿಷ್ಕರಿಸಿದ ಸ್ಪೆಕ್ಟ್ರೋಸ್ಕೋಪಿಯಿಂದ ರಾಮನ್ ಪರಿಣಾಮಗಳನ್ನು ಕಾಣಬಹುದು. ರಾಮನ್ ಪರಿಣಾಮದ ಮುಖ್ಯ ಪ್ರಯೋಜನಗಳೆಂದರೆ ಅಣುಗಳ ಒಳರಚನೆಯ ಅನ್ವೇಷಣೆ. ರಾಮನ್ ರೇಖೆಗಳ ತರಂಗಾಂತರ ಹಾಗೂ ತೀವ್ರತೆಯು ಮಾಧ್ಯಮದ ಅಣುಗಳ ರಚನೆಯನ್ನು ಅವಲಂಬಿಸಿರುತ್ತದೆ. ಹಾಗಾಗಿ ರಾಮನ್ ರೇಖೆಗಳ ಸಹಾಯದಿಂದ ಹಲವಾರು ವಸ್ತುಗಳ ನಿಜ ಸ್ವರೂಪವನ್ನು ಗುರುತಿಸಬಹುದು. ರಾಮನ್ ಪರಿಣಾಮ ಆವಿಷ್ಕಾರವಾದ ಒಂದೇ ದಶಕದಲ್ಲಿಯೇ 2000ಕ್ಕೂ ಹೆಚ್ಚು ರಾಸಾಯನಿಕ ವಸ್ತುಗಳ ಅಣುಸ್ವರೂಪ ಮತ್ತು ಅವುಗಳ ಒಳರಚನೆಯನ್ನು ಕಂಡುಕೊಳ್ಳಲಾಯಿತು. ಭೌತ, ಜೀವ, ರಾಸಾಯನ ಮತ್ತು ಖಗೋಳ ವಿಜ್ಞಾನ ಹಾಗೆ ನ್ಯಾನೋ ತಂತ್ರಜ್ಞಾನದ ಹಲವು ಭಾಗಗಳಲ್ಲಿ ರಾಮನ್ ಎಫೆಕ್ಟ್ ಪರಿಣಾಮವಿದೆ. 1987ರ ಹೊತ್ತಿಗೆ ರಾಮನ್ ಅವರ ಈ ಸಂಶೋಧನೆಯನ್ನು ಆಧರಿಸಿ ಸುಮಾರು 5,000 ಪ್ರಬಂಧಗಳು ಪ್ರಕಟಗೊಳ್ಳುತ್ತವೆ. ಅಂದರೆ ರಾಮನ್ ಪರಿಣಾಮ ಎಂತಹ ಮಹತ್ವದ್ದಾಗಿರಬೇಕೆಂದು ನೀವೇ ಊಹಿಸಿಕೊಳ್ಳಬಹುದು. ರಾಮನ್ ಪರಿಣಾಮದ ಕುರಿತು ಅಂದಿನ ಪ್ರಖ್ಯಾತ ಭೌತ ವಿಜ್ಞಾನಿ ಆಲ್ಬರ್ಟ್ ಐನ್ಸ್ಟೀನ್ ಈ ರೀತಿ ಹೇಳುತ್ತಾರೆ: ವಸ್ತುವಿನಲ್ಲಿ ಬೆಳಕಿನ ಚೆದುರುವಿಕೆಯಿಂದ ಬೆಳಕಿನ ಶಕ್ತಿಯಲ್ಲಿ ಆಗುವ ಬದಲಾವಣೆಯನ್ನು ಗುರುತಿಸುವುದರಲ್ಲಿ ರಾಮನ್ ಮೊದಲಿಗರು. ನನಗಿನ್ನೂ ಸ್ಪಷ್ಟವಾಗಿ ನೆನಪಿದೆ, ಬರ್ಲಿನ್ನ ಭೌತಶಾಸ್ತ್ರ ಗೋಷ್ಠಿಯಲ್ಲಿ ಭಾಗವಹಿಸಿದ ನಮ್ಮೆಲ್ಲರ ಮೇಲೆ ಆ ಆವಿಷ್ಕಾರ ಗಾಢ ಪರಿಣಾಮ ಬೀರಿತ್ತು ಎಂದು. ಇಂತಹ ನಮ್ಮ ಮೇರು ವಿಜ್ಞಾನಿ CV ರಾಮನ್ ಅವರು ಜನಿಸಿದ್ದು 1888ರ ನವೆಂಬರ್ 7ನೇ ತಾರೀಕಿನ ತಮಿಳುನಾಡಿನ ತಿರುಚನಾಪಳ್ಳಿ ಜಿಲ್ಲೆಯ ಕಿರುವಲೈ ಕಾವಲ್ ಎಂಬಲ್ಲಿ. ಅವರ ಪೂರ್ಣ ಹೆಸರು ನಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ, ಚಂದ್ರಶೇಖರ ವೆಂಕಟರಾಮನ್. ತಂದೆ ಚಂದ್ರಶೇಖರ ಅಯ್ಯರ್ ಕಾಲೇಜಿನಲ್ಲಿ ಭೌತಶಾಸ್ತ್ರ ಪ್ರಾಧ್ಯಾಪಕರಾಗಿದ್ದರು. ತಾಯಿ ಪಾರ್ವತಿ ಅಮ್ಮಾಳ್, ಪತ್ನಿ ಲೋಕಸುಂದರಿ. ಮೇಧಾವಿಯಾಗಿದ್ದ ರಾಮನ್ ವಿದ್ಯಾಭ್ಯಾಸದಲ್ಲಿ ಸದಾ ಮುಂದಿದ್ದರು. 1900ರಲ್ಲಿ ತಮ್ಮ 12ನೇ ವಯಸ್ಸಿನಲ್ಲಿ ಮೆಟ್ರಿಕ್ಯುಲೇಷನ್ ಮುಗಿಸಿದ್ದರು. 1904ರಲ್ಲಿ ಮದ್ರಾಸಿನ ಪ್ರೆಸಿಡೆನ್ಸಿ ಕಾಲೇಜಿನಲ್ಲಿ BA ಪದವಿಯನ್ನು ಪಡೆದರು. 1907ರಲ್ಲಿ ಭೌತಶಾಸ್ತ್ರದಲ್ಲಿ MSc ಪದವಿಯನ್ನು ಪೂರ್ಣಗೊಳಿಸಿ ಅದೇ ವರ್ಷ ICS ಪರೀಕ್ಷೆಯಲ್ಲಿ ಉತ್ತೀರ್ಣರಾಗಿ ಕಲ್ಕತ್ತಾದಲ್ಲಿ ಡೆಪ್ಯೂಟಿ ಅಕೌಂಟೆಂಟ್ ಜನರಲ್ ಆಗಿ ವೃತ್ತಿ ಜೀವನವನ್ನು ಆರಂಭಿಸ್ತಾರೆ. ವಿದ್ಯಾರ್ಥಿ ದೆಸೆಯಿಂದ ಮಾಡುತ್ತಿದ್ದ ವೈಜ್ಞಾನಿಕ ಪ್ರಯೋಗಗಳನ್ನು ವೃತ್ತಿ ಜೀವನದಲ್ಲೂ ಅವರು ಮುಂದುವರಿಸ್ತಾರೆ. ಅವರ ಅತ್ಯದ್ಭುತ ಶಕ್ತಿಯೇ ಅವರನ್ನು ಇಂದಿಗೂ ನಮ್ಮ ಸ್ಮೃತಿ ಪಟಲದಲ್ಲಿ ಶಾಶ್ವತವಾಗಿ ನೆಲೆಸುವಂತೆ ಮಾಡಿದೆ. ರಾಮನ್ ಅವರು 1934ರಲ್ಲಿ ಬೆಂಗಳೂರಿನ ಇಂಡಿಯನ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಫ್ ಸೈನ್ಸ್ ನಿರ್ದೇಶಕರಾಗ್ತಾರೆ. ತದನಂತರ 1943ರಲ್ಲಿ ರಾಮನ್ ಸಂಶೋಧನಾ ಕೇಂದ್ರ, ನಾವೀಗ RRI ಅಂತ ಕರಿತೀವಿ, ಅದನ್ನ ಬೆಂಗಳೂರಿನಲ್ಲಿ ಸ್ಥಾಪಿಸ್ತಾರೆ. ಬೆಂಗಳೂರನ್ನು ತಮ್ಮ ಕಾರ್ಯಕ್ಷೇತ್ರವನ್ನಾಗಿ ಮಾಡಿಕೊಂಡು ರಾಮನ್ ರಿಸರ್ಚ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಎಂಬ ಸಂಶೋಧನಾ ಸಂಸ್ಥೆಯನ್ನು ಸ್ಥಾಪಿಸಿ ಅನೇಕ ಸಂಶೋಧನೆಗಳನ್ನು ಅವರು ಮಾಡಿದ್ದಾರೆ. ರಾಮನ್ ರಿಸರ್ಚ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಇಂದಿಗೂ ಕೂಡ ವಿಶ್ವದ ಪ್ರಮುಖ ಭೌತಶಾಸ್ತ್ರ ಸಂಶೋಧನಾ ಸಂಸ್ಥೆಯಲ್ಲಿ ಒಂದಾಗಿದೆ. ರಾಮನ್ ಅವರಿಗೆ ಸಂದ ಪ್ರಶಸ್ತಿ ಪುರಸ್ಕಾರಗಳು ಅನೇಕ. ಆಗ್ಲೇ ಪ್ರೊಫೆಸರ್ ನಾಗಣ್ಣ ಅವರು ಸುಮಾರು ಆಗ್ಲೇ ಹೇಳಿ ಆಯ್ತು. ಅದರಲ್ಲಿ ಮುಖ್ಯವಾದ್ದು ಅಂತಂದ್ರೆ 1924ರಲ್ಲಿ ಲಂಡನ್ನಿನ ಫೆಲೋ ಆಫ್ ರಾಯಲ್ ಸೊಸೈಟಿಗೆ ಆಯ್ಕೆ ಆಗ್ತಾರೆ. ಆಮೇಲೆ ನೈಟ್ವುಡ್ ಬ್ರಿಟಿಷ್ ಪದವಿ ಕೂಡ ಅವರನ್ನು ಹುಡುಕಿಕೊಂಡು ಬರುತ್ತದೆ. 1930 ಈಗಾಗಲೇ ನಾನು ತಿಳಿಸಿದಂತೆ ನೊಬೆಲ್ ಪ್ರಶಸ್ತಿ ಅವರನ್ನು ಹುಡುಕಿಕೊಂಡು ಬಂತು. ಇವೆಲ್ಲದಕ್ಕೂ ಕಿರೀಟವೆಂಬಂತೆ 1950 ಭಾರತ ಸರ್ಕಾರ ಭಾರತ ರತ್ನ ಪ್ರಶಸ್ತಿ ನೀಡಿ ಗೌರವಿಸಿತು. ವಿಜ್ಞಾನವೇ ದೈವ, ಸಂಶೋಧನೆ ಉಸಿರು ಎಂದುಕೊಂಡಿದ್ದ ರಾಮನ್ ಅವರು 1970 ನವೆಂಬರ್ 21 ತಮ್ಮ 82ನೇ ವಯಸ್ಸಿನಲ್ಲಿ ಅಲ್ಲೇ RRI ರಾಮನ್ ರಿಸರ್ಚ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ನಲ್ಲೇ ಅವರು ಇಹಲೋಕವನ್ನು ತ್ಯಜಿಸ್ತಾರೆ. ಅವರು ಭೌತಿಕವಾಗಿ ರಾಮನ್ ಅವರು ನಮ್ಮೊಡನೆ ಇರದಿದ್ದರೂ ಸಹ ಅವರ ಆವಿಷ್ಕಾರಗಳು, ಕೊಡುಗೆಗಳು ಅವರನ್ನು ಸದಾ ನೆನಪಿನಲ್ಲಿ ಇಡುವಂತೆ ಮಾಡಿವೆ. ಯುವ ವಿಜ್ಞಾನಿಗಳಿಗೆ ರಾಮನ್ ಅವರ ಸಂದೇಶ ಇಷ್ಟೇ: ಸಂಶೋಧನೆಗಳ ಸಫಲತೆಗೆ ಅತ್ಯಾಧುನಿಕ ಉಪಕರಣಗಳೇ ಆಗಬೇಕಿಲ್ಲ, ಸ್ವತಂತ್ರವಾದ ಆಲೋಚನೆ ಮತ್ತು ನಿರಂತರ ದುಡಿಮೆ ಬೇಕು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು 1986 ನ್ಯಾಷನಲ್ ಕೌನ್ಸಿಲ್ ಫಾರ್ ಸೈನ್ಸ್ ಅಂಡ್ ಟೆಕ್ನಾಲಜಿಯು ಭಾರತ ಸರ್ಕಾರಕ್ಕೆ ಫೆಬ್ರವರಿ 28 ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನವನ್ನಾಗಿ ಆಚರಿಸಲು ಮನವಿಯನ್ನು ಸಲ್ಲಿಸುತ್ತದೆ. ಇದರ ಮನವಿಯನ್ನು ಒಪ್ಪಿದ ಅಂದಿನ ಸರ್ಕಾರ ಪ್ರತಿ ವರ್ಷ ಫೆಬ್ರವರಿ 28 ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನವಾಗಿ ದೇಶದಾದ್ಯಂತ ಆಚರಿಸುವಂತೆ ಘೋಷಿಸಿತು. ಮೊದಲ ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನವನ್ನು ಫೆಬ್ರವರಿ 28 1987 ಆಚರಿಸಿತು. ತದನಂತರ ಆಚರಣೆ ಇಂದಿಗೂ ಕೂಡ ಜಾರಿಯಲ್ಲಿದೆ. So as I mentioned in Kannada, Science Day, also known as National Science Day, is celebrated in India on February 28th every year to commemorate the discovery of the Raman effect by the Indian physicist Sir C.V. Raman on February 28, 1928. The Raman effect is a phenomenon in which a beam of light passing through a transparent material is scattered in a way that can reveal information about the molecular structure of the material. The theme of National Science Day in 2023 is Global Science for Global Well-being. As India enters 2023, the theme indicates the country's emerging global role and rising visibility in the international arena. Science Day serves as an opportunity to celebrate the achievements of scientists and their contributions to society. It is a day to recognize the importance of science and technology in our daily lives and to encourage the pursuit of scientific knowledge and research. It also aims to raise public awareness about the significance of science and to promote the study of science and technology in schools as well as in universities. Every year on this day is celebrated as a National Science Day by University of Mysore to raise an awareness on the importance of science that has in our daily lives. The topic of today's special lecture being delivered by Professor T.P. Singh, Research Professor, AIIMS, New Delhi, on therapeutic applications of innate immunity proteins against microbial infections. It is a very interesting topic, and it is my pleasure to welcome and introduce the speaker to the audience. Professor T.P. Singh works as a DST SCRB Distinguished Fellow at the All Indian Institute of Medical Sciences, New Delhi. He is also an honorary distinguished professor of the University of Mysore and an honorary visiting professor of the DST Institute of Nanoscience and Technology, Mohali. His contributions in the fields of X-ray crystallography, structural biology, protein structure determination, peptide design, and drug discovery are globally well known. His current focus is mainly on the structure and functional studies of innate immunity proteins and their therapeutic applications. He has published more than 450 research articles and contributed more than 625 protein structures in the protein data bank. He obtained his MSc degree from the University of Allahabad in 1971, PhD from the Indian Institute of Science, Bangalore in 1976, worked as a postdoctoral researcher at the Max Planck Institute for Biochemistry, Munich during 78 to 80, and he has also obtained honorary doctorate from the Karnataka State Open University, Mysore in 2010. He was the president of the Indian Biophysical Society, Indian Crystallographic Association, Biotech Research Society of India, Bioinformatics and Drug Discoveries Society of India, and vice president of the Indian National Science Academy, that is INSA. He is a fellow of the World Academy of Sciences, the Indian National Academy, the Indian Academy of Sciences, the National Academy of Sciences, and the Biotech Research Society. He received Professor G.N. Ramachandran Award of the Kerala State Council of Science, Technology and Environment, Professor G.N. Ramachandran Award of the Society of Biological Chemists of India, Professor G.N. Ramachandran CSIR Gold Medal for Excellence in Biological Sciences and Technology, Professor G.N. Ramachandran 60th birthday commemoration INSA Medal, and Shastra G.N. Ramachandran Award for Excellence in Science. On behalf of University of Mysore, I welcome you, sir, for this National Day program. I request our Honorable Vice Chancellor to present a bouquet to Professor T.P. Singh. ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯದ ನಮ್ಮ ನಿಮ್ಮೆಲ್ಲರ ನೆಚ್ಚಿನ ವಿಶ್ರಾಂತ ಕುಲಪತಿಗಳಾದ ಪ್ರೊಫೆಸರ್ ಎಸ್.ಎನ್. ಹೆಗ್ಡೇರವರು ನಮ್ಮ ವಿಶ್ವವಿದ್ಯಾಲಯವು ನಡೆಸುವ ಎಲ್ಲಾ ಶೈಕ್ಷಣಿಕ ಅಭಿವೃದ್ಧಿಗೆ ಸಂಬಂಧಿಸಿದಂತೆ ಎಲ್ಲಾ ರೀತಿಯ ಮಾರ್ಗದರ್ಶನ ಮತ್ತು ಪ್ರೋತ್ಸಾಹವನ್ನು ನೀಡುತ್ತಾ ಬಂದಿದ್ದಾರೆ. ಇನ್ನು ಮುಂದೆಯೂ ಸಹ ಸಲಹೆ ಮತ್ತು ಸಹಕಾರವನ್ನು ನೀಡುತ್ತಾರೆ ಎಂಬ ಆಶ್ವಾಸನೆಯೊಂದಿಗೆ ಮಾನ್ಯ ಪ್ರೊಫೆಸರ್ ಎಸ್.ಎನ್. ಹೆಗ್ಡೆ ಅವರಿಗೆ ನಮ್ಮ ನಿಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ನಮ್ಮ ಸೈನ್ಸ್ ಡೀನ್ ಅವರು ಬೊಕೆಯನ್ನು ಪ್ರೊಫೆಸರ್ ಎಸ್.ಎನ್. ಹೆಗ್ಡೆ ಅವರಿಗೆ ಕೊಡ್ಬೇಕಂತ ನಾನು ಕೇಳ್ಕೊಳ್ತೇನೆ. ಇಂದಿನ ಸಭೆಯ ಕಾರ್ಯಕರ್ತರಾದ ಮತ್ತು ಇಂದಿನ ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನಾಚರಣೆ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ವಹಿಸಿರುವ ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯದ ಮಾನ್ಯ ಕುಲಪತಿಗಳಾದ ಪ್ರೊಫೆಸರ್ ಮುಜಾಫರ್ ಎಸ್ ಅಸಾದಿರ್ ಅವರಿಗೂ ನಮ್ಮ ನಿಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ಕುಲಸಚಿವರಾದ ಶ್ರೀಮತಿ ಶೈಲಾಜಾರ್ ಅವರು ಬೊಕೆಯನ್ನು ಕೊಡಬೇಕಾಗಿ ಕೇಳ್ಕೊಳ್ತೇನೆ. ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯದ ಮಾನ್ಯ ಕುಲಸಚಿವರಾದ ಶ್ರೀಮತಿ ಶೈಲಾಜಾರ್ ಅವರಿಗೂ ಕೂಡ ನಾನು ಆತ್ಮೀಯ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. ಹಾಗೂ ನಮ್ಮೊಂದಿಗೆ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ನಿಕಾಯದ ಡೀನರು ಹಾಗೂ ನನ್ನ ಸಹೋದ್ಯೋಗಿ ಮಿತ್ರರಾದ ಪ್ರೊಫೆಸರ್ ಎಚ್.ಟಿ. ಬಸವರಾಜಪ್ಪರವರಿಗೂ ಕೂಡ ಆತ್ಮೀಯ ಸ್ವಾಗತವನ್ನು ನಾನು ಬಯಸುತ್ತೇನೆ. ನಮ್ಮ ವಿಶ್ವವಿದ್ಯಾಲಯದ ಹಣಕಾಸು ಅಧಿಕಾರಿಗಳಾದ ಶ್ರೀಮತಿ ಸಂಗೀತಾ ಗಜಾನನ್ ಭಟ್ರವರಿಗೂ ಆತ್ಮೀಯ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. ಹಾಗೂ ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾಲಯದ ವಿಶ್ರಾಂತ ಕುಲಪತಿಗಳಾದ ಪ್ರೊಫೆಸರ್ ಕೆ.ಎಸ್. ರಂಗಪ್ಪ ಸರ್ ಕೂಡ ಇಲ್ಲಿದ್ದಾರೆ. ಅವರಿಗೂ ಕೂಡ ನಾನು ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. ಕೊನೆಯದಾಗಿ ಸಿಂಡಿಕೇಟ್ ಹಾಗೂ ಶೈಕ್ಷಣಿಕ ಮಂಡಳಿಯ ಸದಸ್ಯರಿಗೂ, ಎಲ್ಲಾ ನಿಕಾಯದ ಡೀನರ್ಗಳಿಗೂ, ಸಹೋದ್ಯೋಗಿ ಮಿತ್ರರಿಗೂ, ಆಹ್ವಾನಿತರಿಗೂ, ಸಂಶೋಧಕರಿಗೂ, ವಿದ್ಯಾರ್ಥಿಗಳಿಗೂ, ಅಧ್ಯಾಪಕ ಮತ್ತು ಅಧ್ಯಾಪಕೇತರ ವೃಂದದವರಿಗೂ ಹಾಗೂ ಮಾಧ್ಯಮ ಮಿತ್ರರಿಗೂ ವಿಶ್ವವಿದ್ಯಾಲಯದ ಪರವಾಗಿ ಆತ್ಮೀಯವಾದ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. ಜೈ ಹಿಂದ್, ಜೈ ಕರ್ನಾಟಕ.
ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಮಾನ್ಯ ಕುಲಸಚಿವರು ಪರೀಕ್ಷಾಂಗ ಇವರನ್ನ ಪ್ರೊಫೆಸರ್ ಬಸವರಾಜಪ್ಪನವರು ಹೂಗುಚ್ಛ ಕೊಡೋದ್ರ ಮೂಲಕ ಸ್ವಾಗತಿಸಬೇಕು ಅಂತ ಕೇಳ್ಕೊತಾ ಇದ್ದೀನಿ. Thank you, Professor Gnan Prakash, for giving us the background in beautiful poetic Kannada. Our great poet Kuvempu would have felt very happy hearing your description, because Kuvempu inspired the university teachers to write in our mother tongue. The university professors, drawn from all faculties, realized the wisdom in Kuvempu's persuasion, and they not only delivered lectures in Kannada in villages and Mofussil areas, in tune with the wishes of our founding fathers, the great Maharaja, but the lectures were also brought out subsequently in book form. Thank you very much, sir. Now, Professor H.T. Basurajappa, Dean of Faculty of Science, is going to give the preamble of the Science Day. He has published 556 research papers, especially on Precambrian tectonics. In 1998, he has won the Young Scientist Award for Applied Sciences. This award was in recognition of their finding of collegal shear zone. He has produced 14 PhDs. All of them are very well settled. Recently, Dr. Basurajappa has found Vedavati shear zone in Andhra Pradesh along with his students. has been a teacher for the last 38 years. He takes pride in the fact that all his education has been in the University of Mysore. He has been a gold medalist throughout. I request Professor Basurajappa, Dean of Faculty of Science, to say a few words about the National Science Day.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Good morning. My beloved dignitaries on the dais and off the dais, all syndicate members, my colleague, deans of the other faculty, academic council members, officials of the university, all teaching and non-teaching staff of the university, and young researchers, and all my students' friends, media and press people. Happy National Science Day, all of you. Today, we have gathered here to celebrate a National Science Day. This National Science Day is celebrated in India on 28th February each year to mark the discovery of the Raman effect by great Indian physicist C.V. Raman. Sir C.V. Raman, also known as Chandrasekhara Venkata Raman, born on 7th November 1888 in Tiruchirappalli, then Madras, now Chennai in Tamil Nadu. He did his BSc Honours from Presidency College, University of Madras. His first research paper was on diffraction of light, which was published in the year 1906, while he was still a graduate student. He was awarded Nobel Prize in Physics in the year 1930, and he was the first Asian to receive this Nobel Prize in any of the science branches. In Karnataka, also C.V. Raman has worked. He moved to Bangalore in the year 1933 and above, and he became the first director of the Indian Institute of Science. He founded the Indian Academy of Science the same year. He also established Raman Research Institute in India, that too in Bangalore, 1948. Later, 1954, the government of India honored him the first Bharat Ratna Award. The National Science Day celebration includes public speaking, science exhibitions, and easy writing competition, quiz, science lectures, and many more activities to spread message about the importance of science and to encourage students to learn science among the younger generation. It is celebrated to discuss all the issues and implement new technologies for better life on the earth. This year, theme for National Science Day 2023 is Global Science for Global Well-being. Many global problems, even today, like climate change, civil wars, water contamination, global warming, poverty, diseases, etc., have not solved so far. Still, much research has to be done in this regard. Every day, science is getting advanced. We need to get updated with new technologies and try to solve the various problems which we are seeing every day and today also. Lastly, to conclude, I want to quote by Louis Pasteur: "Science knows no country because knowledge belongs to humanity, and it is the torch which illuminates the world." Once again, happy National Science Day, all of you. Thank you, one and all. Thank you very much.
Thank you, Professor Basurajappa, for your short and sweet speech. Professor S.N. Hegde, as Vice Chancellor for University 2 decades ago, asked promotion-seeking young lecturers whether they have done any research. He came down very heavily if they argued that they were good teachers and not interested in doing research. The reason is that Professor Hegde himself is an extraordinary researcher. He investigated half a dozen major research projects, including those funded by MacArthur Foundation USA and Wildlife Society New York, USA. Was a Commonwealth postdoctoral fellow at the University of Reading, UK between 1974 and 1976. Was a Fulbright visiting professor at the University of Arizona, USA between 1992 and 1993. Professor Hegde is an acclaimed speaker. He was an elected president of Indian Society for Comparative Animal Physiology, 1994-1998. Elected president of Forum for Former Vice Chancellors of Karnataka, FVCK, 2018 and 22. As I said just now, Professor Hegde is an acclaimed public speaker, and his weekly or fortnightly columns on higher education is very, very thought-provoking. Now I request Professor S.N. Hegde, our former Vice Chancellor, to give us the chief guest's speech.
Telling Namaskara. Esteemed dignitaries on the dais, members of teaching faculties in the audience, including former Vice Chancellor Professor K.S. Rangappa, invitees, and my dear students. Science or Science Day, or any day for that matter, is not only for celebration, not only for observation. These are the days for taking stock of where do we stand in terms of science and scientific fervor and temper, not only in the universities, unfortunately, even there it is declining, but also in society. What kind of society we have? How much do we believe in science? In the United States, science is made in the laboratory by the scientists and then passed on to the people in society. They adopt it very faithfully. There are many things that we need to do in this country by the time we celebrate 100 years, centenary of our independence, that is 2047. Professor Singh, our esteemed speaker this morning, has come all the way from Delhi, and he has something to tell us about the immune apparatus of our body and our responses to infections. I have certain general remarks, general observations to make. It won't be long. Ancient Indian history tells us, barring fictions like Pushpak Vimans, plastic surgery, and there are so many other things. Please let us not take them very seriously. Our scriptures are full of strictures, full of aberrations. Whatever is best in Upanishads or Veda or Gita or something, we have to take. The remaining, you have to simply reject. Our history tells us about our knowledge on civil engineering. For instance, Harappan, civilization. Architecture, as we see in temples. Ayurveda, the work of Sushruta and Charaka. Astronomy, the work of Aryabhatta, Bhaskara and other astronomers, and more than anything else, the contribution of Indian mathematicians as a group in terms of zero, Z-E-R-O, is a monumental, is a signal, accomplishment and contribution to the world by Indian mathematicians. It's not of one person. It is supposed to be contribution of a group of, mathematicians. Around 30s and 40s of the 20th century, we had distinguished scientists like C.V. Raman, Meghnad Saha, J.C. Bose, Homi Bhabha, and others, whose contributions were treated on par with those of their Western counterparts. There was a debate. What happened to us? At that time, we were really in the forefront, like some of our industries, for instance, steel industry in the 17th and 18th century, as good as, the same elsewhere in the world. Ceramics, I think except glass, we had good know-how about metallurgy. But what happened? Why did we lose this, leadership? It's a big question. It's unequivocal that we have made spectacular progress in nuclear science, space research, biotechnology, and agriculture, and in other areas. We also witnessed of scientists like C.N.R. Rao, semiconductors, M.S. Swaminathan, agriculture, and I don't think many people have heard about Professor Subbarao, Dr. Singh, Dr. T.P. Singh. Dr. T.P. Singh, I'm addressing you. Professor Subbarao is a world-renowned statistician. He was the director of the Indian Institute of Statistics. He was in Mysore. Yeah, is there any correction? Which Rao? C.R. Rao. Sorry, C.R. Rao. Some mistake I have made. And, I happened to be there in one of the Commonwealth Vice Chancellor Conference, Cyprus, yes, where he was honored. And later on, he was in Mysore also. Incidentally, I must tell you that he asked me, Mr. Vice Chancellor, can you trace a letter supposed to have been written by Mysore University inviting Albert Einstein to come and occupy this chair in physics? Believe me, I did, try tremendously to trace that letter. But as it happens, documentation in our parlance is very bad, very bad. I could not trace that letter. But Einstein later on went to the US and then, got the Nobel Prize and so on. Indians like Har Gobind Khurana, S. Chandrasekhar. Chandrasekhar was teaching in the University of Chicago. He had students, a class of 2 Chinese students, and to teach them, he used to drive, about 50 miles or so. This is what it was written. And the student got Nobel Prize earlier than the Guru. Incidentally, he opposed with the navy of C.V. Raman. C.V. Raman was the elder brother's son, Dr. S. Chandrasekhar. Venkatraman Ramakrishnan studied in Baroda. I knew his father, Professor Ramakrishnan, was a professor of biochemistry at MS University, Baroda. And this Venki, popularly called, is now in UK, recently was in India. And did he come for our centenary? Yeah. Professor Rangappa was able to get many, Nobel laureates. This Venki goes to University of San Diego to do PhD in physics. And then goes to UK and works on RNA and gets a PhD in chemistry, and also Nobel Prize. So Venkatraman Ramakrishnan, Amartya Sen, Abhijit Banerjee, who went abroad for higher studies and could get Nobel Prizes. And mathematicians like Manjul Bhargav, he also came during our centenary of, University of Mysore centenary celebrations. And Subhas Kote, I think Subhas Kote, So they were all given the field medals, supposed to be equivalent to Nobel Prize, because there is no Nobel Prize in mathematics. It's equivalent to Nobel Prize. Indian teams seem to blossom very well abroad. Indian talents blossom very well abroad. However, there are hurdles and stumbling blocks that prevent young Indian scientists from shining to their fullest potential. Again, question mark. When people do so well when they go abroad, but they're not that much shining, when they're here on our own soil. Many of our scholars are quite prominent. Perhaps they appear to be not eminent enough to make a global dent. There's a difference between the two. I've been mentioning about this on and off. Prominence and eminence. A question that is often asked in many circles is, why do our stars not shine onshore but become part of the bright galaxy offshore? We're talking about offshore, distance education, etc., etc. Onshore, indigenously, we have got bright fellows, brilliant fellows. Not at all next to somebody, but they don't shine. They don't make a dent, or they don't really figure in that list of eminent people in the world, with the exceptions, of course. There are exceptions. The reasons for this dualism could be many. There are two aspects of our science. One in India, the other one, those who have gone abroad and they're shining there. My personal perception is that in our schools, colleges, and universities, our teachers fail to identify students of latent merit and exceptional promise. This is very important. Right from our schools and colleges and universities, we do not have many teachers to identify the promise, latent merit in our students. After all, it doesn't exist in everybody. Many students come here for different purposes. Their aspirations are different. Their preparations are different. They come from different socio-economic backgrounds. But nevertheless, there could be very promising students, and a good teacher, a conscientious teacher, a sincere teacher, not only should lecture in the classroom and conduct examination and evaluate the papers and give them rank and so on, but his job is to identify if there is a spark. That our teachers have not been able to do it very well. Maybe exceptions here and there, but otherwise. I've been always saying, university teacher is not only a classroom teacher. Beyond lecture in the class, he is a mentor. He is a motivator. He is an inspirer. And he should tell the promising student, once they identify, such students, where he should go for further study. Not necessarily in everything in Mansa Gangotri. They come here for undergraduate, do postgraduate, PhD, and then try hunt for a lecturership and so on, and settle down once for all. Forget the whole thing. So job is to identify where do we have, good merit. Someone rightly said recently, I read, it requires talent to identify talents. Very meaningful. It requires talents to identify talents. Ordinary teacher cannot identify good talents. Only a talented fellow, only a motivated, committed teacher can identify talents. And we need to do this work. Science will not improve automatically. After all, meritocracy breeds meritocracy through generations. Motivation and mentorship are crucial at turning points of our students' career. At the right moment, if you give them a push and tell them where to really further studies one can make. For instance, close by, we have got one of the best institutions, Indian Institute of Science. Not all can get in there easily, but those who can get in, not through influence, but on their own merit. As life begets life, meritocracy breeds a meritocracy. And if it breeds over generations, then you will have the, good result. Absolute autonomy to our higher education and research institutions, and more facilitation and less regulation, if ensured perennially, might improve the current situation in the next 25 or 30 years. Not 1 or 2 years. This has to be sustained. We're talking of sustained development goals. That education is also one of the items there. This has to be nursed and nourished through generations. Then only we can think of some leadership in some areas of science, not in all areas. Attaining and retaining quality and excellence are formidable challenges that demand, commendable efforts. It is not easy to attain. And even if we attain, say A plus A second, our own experience here, it's not easy to sustain it. You may not be able to sustain it. And today's situation is that many institutions, in Karnataka and in the country will not be able to sustain. There are many reasons. There are inherent difficulties and drawbacks and deficiencies. With the result, you will not be able to sustain this high quality, productive work. As a country, we have to embrace the ethos that investment on good education, including science education, is the one that yields invaluable dividends. Many people said, it's not only my saying, there is no other investment better than the one on education. Of course, health comes next. Good education, quality education. Even if people come from rural areas, and we have a large number of people coming rural areas, if they don't have talent, we need to have the ability to create talents. That's what I meant. To identify talents, you should have talents. You can't say that they're all useless. They come from rural areas. They cannot write, nor they can read. This kind of excuses are not pardonable. If they don't have merits, if they don't have talents, you need to create talents. And only a talented teacher can create talents. It's a great responsibility, which people don't understand. With all good salaries and perks and privileges, the contribution of the faculty to the uprising of merited students. The remaining will pass, they will get a degree, they will end up as administrators or clerks or whatever. It's a free country and they are free to choose any evocation of their choice and options. But I am talking about those who are showing promise of becoming good scientists, of becoming good researchers. I have not come across. In my own career, I have not been, encouraged by people. People, they gave lectures, textual, they transmitted the textual knowledge, little in advance. When we read the textbook later, we come across that our teacher has copied it from this, book and all. But no inspiration, no motivation. If somebody is good in a subject, whether zoology of my subject or history, a good teacher of history should tell where is the best bet, where he can really, whether he can go for IAS or KAS or something beyond that. That is not happening in our colleges and all routine rituals. What people perform is ritualistic. And then they wash up by February or March to conduct examination and go home. Science, our educational, investment should be increased because it returns rich dividends. In recent years, Japan, China, Singapore, and South Korea have demonstrated this aspect. Heavy investment on higher education, professional education. It seems in China, 1990 revolution, and subsequent years, the investment on education. And today, we can witness how much they are broken. Even South Korea, a small country like Singapore. Science and technology as powerful instruments and driving forces of growth and development and bringing economic prosperity and general well-being of people. Science and technology will really help us build up our resources, build up our know-how, and become a knowledge economy. Scientific discoveries and inventions offer solutions to a spectrum of our problems of life and living. It's not mantras. It's not, slokas. We're talking about a real science that's made for the public good. Last 1 or 2 points. Nagana, can I take 1 or 2? Or is it? Okay, 2 minutes, yeah. The task of strengthening science, technology is an offshoot of science. For example, electricity, when it was discovered by Thomas Alva Edison, more than 200 years ago, was a pure science. Nobody ever dreamt, including Edison, that this would develop into technologies in subsequent, years. So science, pure science, and if at all it has to be made, it has to be produced, we cannot entrust this job to national laboratories alone. Professor Singh, we have made mistakes by diverting our funds, precious funds, only to national laboratories run by CSIR and other laboratories. And I must, quote here, as appointed by Nobel laureate S. Chandrasekhar, when he, after the Nobel, award, he came to India, the famous astrophysicist of black hole fame. He appointed our universities where we have the best, young brains, not in national laboratories. The best young people are found in the university in the age of 18 to 23, either BSc or MSc. So this kind of rare, assemblage of good brains, you don't find in national laboratories. This is not to say that they're not doing good work, but in addition to that, our young people who are in the university must be supported with adequate funding for quality research. And I'm very sorry to say that the research funding has, declined. Research projects are not being encouraged and so on. Professor Chandrasekhar said in the US, unlike in India, universities are regarded as cradles of fundamental research from which all applied sciences emerge. It's the fundamental research that's, the mother of all these. Although NAP 20 has proposed National Science Foundation, NAP has proposed many things. One of the things is the National Science Foundation. But I do not know what has come out of this proposal, how much money they are allocating for science and scientific research. Scientific advancements take time to fructify. There's no magic wand. We cannot have breakthroughs in science overnight. Science has to be nourished successfully from the school itself. Where is science in schools and colleges? I think our Director of College Development Council is here. If you get into physics laboratory or chemistry laboratory, what kind of instruments you find? And even if there are some grants for schools and all, it is very safely kept under lock and key by the headmaster. Nobody can touch. And the headmaster says that, no, sir, if you allow them to, they will spoil. He's scared of the instruments being spoiled. This is the kind of apathy. This is the kind of carelessness. And how can we progress in science? Science has to be nursed. If our country has to be transformed as a developed nation, the role of science is indeed crucial. We need to spend at least 2% of our GDP. We have not been able to on science and research and development. Less than 1% we are spending. Science is cultivated by scientists, but it has to be adopted by the society. Like health and education, science is for life and science is for living. It is not only for life, it is also for living. Last one, Vijnanam Sada Gilge. Thank you very much.
Thank you very much, sir, for as brilliant as always. Ladies and gentlemen, only last week, Professor Hegde enlightened us on the phenomenon of entry of foreign universities in India, the pros and cons of such an eventuality. Again, here again, he has enlightened us on the importance of identifying talents, which nurtures merit and promotes intellectual ambience in a desirable way for our own good. Thank you very much, sir. Professor T.P. Singh, the doyen of Indian science, is a distinguished professor in our university, apart from other noteworthy accomplishments which have brought our country great pride. It speaks volumes of the vision of our former Vice Chancellor, Professor K.S. Rangappa, that he brought Professor T.P. Singh and the likes of him again and again amidst us, because Professor T.P. Singh's very presence inspires us in very many ways. Without much delay, I request Professor T.P. Singh to deliver the National Science Lecture on the topic, Therapeutic Applications of Innate Immunity Proteins Against Microbial Infections. Thank you. Over to you, sir.
Thank you so much. You will have slides somewhere? Okay. Okay. So in the meantime, namaskar. Nanaki Kannada also gotu. I think this University of Mysore I can do it. Yeah, I can do it. I can pointer. Pointer also. Where the slides will be? You can see here. Oh, there. Slide right and move from here. Here? First of all, I will request that the lights can be a little bit dim, little bit. If you can. Otherwise, it becomes like a Vigyan Bhavan episode. If you can dim a little bit. I must say that my presentation will be shorter than what Professor Gyan Prakash gave and will be less technical than what he gave. So I think we don't have time. I'll cut down things a little bit. But before that, I should say that this university, I have understood that produces big scientists and produces big vice chancellors. And also yesterday I met a couple of colleagues from this university, Professor Hegde and Professor Basavarajappa. I found their ideas very good. And many years before, is it very humming or? I can do it here. Yes, sir, you can. Before we begin, I should also say that Professor K.S. Rangappa, who has made enormous contributions in science, and he built 2 universities into such a good shape, that's a really great achievement. And I should also tell you that we should celebrate that he has been elected this year to the World Academy of Science. So this is a great achievement. I am his fan since a long time. He's an extraordinary scientist. It's a pleasure that he's my friend. Here. What you have spoken so much about so many people, I think I need to use, you can see, you cannot see there. You can see? Okay. I have to see with the specs here. You see, if you look at this slide, the first four, lots of times our colleagues, actually yesterday when we had discussions, I was very impressed by what Dr. Hegde said. But I don't agree with him that Indian science is going down. I think Indian science has gone up and is going up and up all the time. There is no ambiguity in my mind. But if you see from this side, the first four were exceptional sparks which happened in the long time. And the last greatest spark came from Professor G.N. Ramachandran, which was after 1947. And his contributions are enormous. But if you see below the 5 achievements, they are of general kind. We all have contributed to those achievements in some way or the other. So this is to be seen that the nature of advancement and development in science and technology has also changed. The last ones, if you see, India is standing out in many areas. As you said, that it's a global way to think. And in all these areas, we are known as the pharmacy of the world. We are doing so much in information technology. We have become, not just become self-sufficient, we are supplying grains to the whole world. And also, I think many areas we have self-sufficient. There is no ambiguity about this. This is a slide I made from what appeared in the newspapers. See, many years before, this is particularly to say the achievement of space. The top part is by Western media. You know, Western media is terrible media. They talk nonsense many times. So if you see the first one, this won't work. New York Times published this cartoon that when India sent, I think India sent satellite to Mars, and then they made this kind of cartoon. And some years later, Times of India published a counter cartoon. Well, you see the clubs have changed. And this Indian Space Department sent 104 satellites. No country has done before. So big things are happening and will continue to happen. This is just to give you a sort of glimpse in that sense. I will not talk much about the subject today because we don't have time. I'll finish in half an hour. But just to give you an idea that we all have been facing, we all the time face actually. But these are the recent pandemics which were caused by several organisms, mainly viruses. But if you see the historical background, there's so many pandemics. They happen and they will keep on happening. The question is that infections will occur all the time. In fact, it is sad if you talk to a microbiologist, they love viruses and bacteria. In fact, we all should love them. They come to interact with us, strengthen our immune system. But what happens that we are so poorly prepared. They want to come and live with us. They want to create strengthen our immune system. But what is happening to us? We are not maintaining ourselves good enough, so we succumb sometimes. But eventually, if we overcome initial period, our immune system becomes better, and these pandemics will keep on happening. So one thing you should know, how to deal with sudden pandemics. There is no idea about the organism. You may not have drugs for them. You cannot make vaccine instantly. And vaccine also can be made against individual strains. They may mutate and then you have a vaccine which may not work. So what is needed is that we all have our germline innate immune system. Our body has those proteins which recognize anything which is external. Now, how potent that is depends on many factors. But in principle, theoretically, we should be protected by our innate immune system. But we did not pay attention to why our innate immune system is not good. We just assume that it is there, it will do its job. but there is a way that this innate immune system can also be exploited as the vaccines and antibodies and antibiotics. And I will just give you a gist, I will not take time, but in very simple terms. Now, just to give you an idea, there are terms used like pandemic, endemic, and epidemic. Pandemic is a worldwide, very intense, and the current one was a pandemic, and you can see that the whole world was affected. And many countries which thought that they are very advanced in medical sciences and science and technology, everything, they suffered the most. Professor Hegde should know that India is a stronger nation in many things. And countries like in Western Europe and USA, much more devastated because they had no idea. And eventually, Indian vaccines and many drug molecules manufactured in India were supplied to rescue many of the countries in the world. So we should see the positive side of our nation. And when we celebrate Science Day, it's not just C.V. Raman. I think C.V. Raman is a notion. As I showed in the first slide, many contributions, and the contributions happen all the time. So just to give you some very simple introduction, because this is a general audience, when we fight these invading microbes, bacteria, viruses, parasites, when they enter our body, how do we fight them? How do we counter them? So there are 4 ways. The first and foremost is that our innate immune system, there are certain proteins involved in this. They recognize them rapidly, and then they interact with them, and then they neutralize. And in principle, they should be able to protect us. They don't protect because our bodies are not ideal. We don't give inputs to our body that they could have enough number of those proteins synthesized. So there are these lacunae. And also, innate immune system, I will come to this later. So that is one thing, the first line of defense. Then, when you are not protected by innate immune proteins, then after a while, when the organism has lived in your body, antibody-specific molecules are synthesized, known as antibodies, and they specifically interact with those organisms and neutralize. And vaccine does the same. Vaccine is something like a dead virus or bacteria, truly, that it makes the proteins which are recognized by antibodies, but doesn't multiply. So there's the vaccine. And of course, many decades before, we were very lucky to have discovered antibiotics incidentally. A lot of things in science previously were happening incidentally. Now actually happen based on knowledge and mind and hard work. So antibiotics were very wonderful molecules, but you hear all the time, the antibiotics are no longer effective because the bacteria or viruses they have developed, they have mutated the sites where these antibiotics bind, so they are no longer able to bind. So the sense is that all living organisms have capacity to mutate themselves to counter the odds. Similarly, you will see that our innate immune proteins, which are not good enough, but if you are exposed continuously to these viruses and bacteria, they also mutate and strengthen. And that is what we need to exploit, that point. So just to give you another idea that once upon a time, when the civilization was happening in certain parts of the world, you see, when we didn't have knowledge of antibiotics or innate immune system or antibodies or vaccines, we had no knowledge of biological systems. How were our old generations, ancestors long ago, were protecting themselves? It's very illuminating. That's why many times when there is an emphasis in old civilizations to learn from the past. So you see these regions where this indicated in the slide, in these regions where people's minds were trained better, they were more civilized, how they thought of what could be used against these infecting organisms. You can see these materials indicated there in the slide. They experimented many things, and by observation, they introduced them, used them to protect. And that is that goes. So geography of science, we should not be worried that the Western world is better at some time or any other. I think this changes all the time. I asked many years before in 1978, I was talking to a colleague in Germany, and I said that Germany was devastated. But as it was fantastic, we were World War II in science. But they were devastated by war. He said that we are coming up again slowly. So civilizations and people, if they had been great in the past, they can become great again. And you can see that we were very wonderful in the ancient times. I think we will rise again, we are rising again. So that is a positive way to think. But you should see that in this part of the world indicated in this slide, they thought of so many materials which were beneficial to protect from infections. But you see, in the next times, the geography changed again because it was a factor of industrialization. So they started, the science is not done in isolation. What I do today here, somebody will use it elsewhere, and somebody will use it tomorrow and day after. What somebody has done today, we will use it tomorrow. So it's a continuity, only location may change, the geography may change. And in this slide, you see that a lot of things, they started from the materials indicated by previous locations. And then they started making advancement on this, and eventually antibiotics were discovered and made, and that's how it went. So this kind of science moves all the time. Now the drawback was why, you see, vaccines can be used against a particular organism, particular strain. But if you are infected already, vaccines have no role to play. You need drugs all the time. So, but since we haven't made many drugs, as you see from this slide, very few drugs were introduced in research labs and in pharma industry. We need to concentrate on drug discovery, and that's a very important aspect. And I'm very happy that many people today are working on drug discovery, including many groups, and particularly group led by Dr. Rangappa is contributing enormously in this field. So we hope that things will improve. Now, this is just slide to indicate when you take antibiotics repeatedly all the time, the infecting organisms will mutate and no longer they will bind. Now, you see, all the time these kinds of things are happening in newspapers and elsewhere. This is so alarming. So this is just to give you important, I will not talk about this because this is slightly technical. There are methodologies research labs are using to develop drugs. And then there's another one. The problem is that many methods we have of drug discovery are trial and error. But the one which is rational requires identification of a protein involved in the disease. And if you know which protein is involved, if you know the structure of this protein, you can design drugs very fast, very rapidly, very potent drug. So doing structures is very important. So I'll give you some idea how to get structures in a very historical perspective, not in technical fashion. See, this is a coronavirus which has been devastating. But if we have ideas of the proteins it has on the surface, the particularly ones which are recognized, which bind to host proteins, and if you know them, you can look at their structures, all the things are done now. This virus will no longer be a problem because we already have this knowledge, but knowing these things takes time. Now, when you see that, I just tell you a little bit, particularly to young generation, you know, discoveries don't happen in isolation in biological sciences particularly. Somebody discovers something here, somebody takes a lead from this, does something else, next one does. So if you see that how the structures of proteins are determined, the first and foremost, you need a source of radiation that is X-ray. Then you need to have your protein samples, which can be isolated clone. Then you have to convert them into crystalline form. And then you have to have devices to decode data and then analyze. And then you have structures and then analyze the structures and then make drugs. So how this progressed in a systematic way, it is just to inspire the young minds that somebody discovered X-rays incidentally. very incident. He was working on something else, but he found some rays which he could not define, called them X-rays. So there was a guy. The next person somewhere else proved that X-rays were able to interact with material and produce some pattern which can be used to characterize the materials. And then next, somebody specifically examined a particular crystal and determined the first structure, that was of sodium chloride. They all kept on getting Nobel Prizes. And that the biggest drawback of Nobel Prize is that it converts a good scientist into a celebrity and makes him useless. And this has happened time and again. So in my opinion, getting prizes and the getting impact than the positive impact. They are busy, many of them earn money by giving speeches also. Then the first time how protein structures were by incident were observed for a protein pepsin, but they did not know how to do that, but they worked out solution after a long time. And eventually first proteins whose structure, they all, for these single things, they got Nobel Prize. Then of course, the first structures are hemoglobin, myoglobin, which are well-known proteins. And then somebody made this DNA fiber diffraction pattern and used some knowledge of modeling and gave the structure of DNA. And somebody again discovered the structure, how proteins fold. And then, of course, from your Indian location, Professor G.N. Ramachandran, who gave the structure of collagen, gave the 5-side map, which is so necessary after he gave for determining any structure for the validation. And then he gave and the component which is known as beta terms. So all these three discoveries, all the discoveries I have shown in the row, starting from X-ray, they are the same level. Now, GNR didn't get a Nobel Prize. That does not mean that he's less than that. In fact, he's superior. Many people who get Nobel Prize, they may be forgotten, but G.N. Ramachandran's contributions are so essential and so important. We use them all the time. So this stream that I showed, the primary idea was to show that they're all of the same caliber. The Nobel Prizes can be sometimes very political and very stupid. There are many stories, but there's no time to tell you. So his was better contribution than all the people you saw in the beginning. Collagen was the most complicated protein to propose a structure, the one he proposed. It was extraordinary work. I'll just show you a little bit more that when contributions are made, when previous times we had no idea of this, whatever you produce, people are talking a lot about artificial intelligence, machine learning, bioinformatics. These tools only become important if you have data sets. So all the structures are done, they are deposited in a data bank, and that is where you can see how the exponential growth is. And just to show you that 3 major continents contribute to structures of proteins nearly equally. And further to this, if you see from this map, the Masu is also part of this contribution Lokanath. So you can see, we can be darker than what we are seeing in this map, but these are the 4 locations you can see. You have Eastern USA, Western Europe, India, China, and Japan. These are the 4 locations where from major structures are contributed. And we also have done lots of structures to contribute to this database. And we have been doing this, we are still contributing. And I just want to show this slide. This slide is not important. I particularly wanted to show this slide. This LKL is NKL is nothing but Lokanath. I wanted to highlight contribution by the scientists from this lab. And you can see that how people have individual labs have contributed. This is historically these labs made contributions. Now, of course, scene is changing. It's not just labs, it's growing rapidly in all directions. So these people, the number of structures from individuals came out like this, and this NKL you see is the man from Mysore. So no doubt, Mysore has produced highly extraordinary scientists before, And we should be proud those who work here and produce good science, not those who go abroad and do something. There's no difference in contribution made by your soil and from Western world. These days, one thing is very commonly stated. All global major brand companies, their CEOs are Indian. It is not that the education there has made a difference. They all were educated here. So people in general of Indian origin are extraordinary. The human resource from our country, all these young people should know they have bright future and they are one of the best materials in the world. I think this is our best wealth. It needs to be exploited, and I think it's being exploited. I want to inform Professor Hegde that there is no need to be pessimistic on this. Indian things are improving rapidly. There was one seminar in Mysore Infosys Center. One famous professor from Canada was participating in this. He said that I haven't seen the brighter and enlightened young minds as I saw in India in the Infosys Center in Mysore. So you can imagine that this is the impression in the world. We many times think less about ourselves. And I think that is what historically Vivekananda many times tries to tell Indians, that don't have inferiority complex. You are superior to all. And this is what is happening. So just something more, that you generate data, you deposit in the data banks, which is necessary. All data we generate, we should deposit in the data banks, all kinds of data banks. Then those who can produce data and submit, they may not have enough time to go deep into this analysis. And then you need to analyze data, compare with other lot of data in the data set, and you can come out with a lot more useful information. And from this slide, you can see 3 continents are, their activities are nearly similar. And if you see in the next slide, who enters, who logs into this database, India is only number 2. So these are very important indicators and in the present context. And primary aim is that basically, genetically, biologically, Indian minds are very bright, brighter than anywhere else in the world. And that should be the confidence young people should move on. When I was a student, we used to feel that we were behind time. Now, when I become a senior professor, I feel we should have been now. Now is the time when excitement is happening in biological sciences, in many areas of science. Now, just a couple of slides I will give here. When you talk about infections caused by what you call invading microbes, the organisms in this context take this virus, coronavirus. How does it infect? It enters your body. The entry points are your nose, mouth, eyes, main entry points. Anywhere if you have entry possibilities, they enter, maybe injuries can also, but these are the main things, the airborne virus. Now, whenever any infecting organism enters your body, it obviously enters to live on the resources of your body. And if your resources are limited, it will consume all the resources and you will eventually vanish. But as soon as this enters, there are certain proteins in your body are expressed and overexpressed. If your body is well prepared, these proteins will be overexpressed and they will counter them aggressively and will not allow them to multiply. Now, these are the proteins which are important, and these are the proteins which are part of the innate immune system. So if we can strengthen them, if we can provide inputs to these proteins, we can protect ourselves. So I think I will not take longer time. Just finish in some more minutes, but the time is very short. In my group, we have worked on several of these proteins of the innate immune system. This slide, yellow colored proteins are the ones which are very simple, well known, but some of them were not at all studied. So we have studied these proteins, did their detailed structures, and have come to some stage. So this is one section there. This section is all innate immune proteins. So this is, I will just quickly finish. So there are 4 members mainly. They are expressed wherever your virus enters your body, they are overexpressed. And they use different mechanisms to counter virus. They don't use the same mechanism, so that it's a different variety of weapons. So by these mechanisms, they try to neutralize. I will just tell a few lines, a few words on this. The first one, which is known as peptidoglycan recognition protein. Now, all bacteria and viruses and other things, they have certain molecules on their cell wall. Human cell doesn't have a cell wall, that kind of structure. So they are unique to these organisms. So these proteins bind with high affinity to these cell walls. And higher the affinity they bind, faster they neutralize the invading microbes. So this one, the way, the first one, I think I will just give you just some. So what this protein is, how capable is this protein? Now, the way bacteria and viruses mutate upon countered by medicines and vaccines, human innate immune proteins or animal innate immune proteins also modify. So we examine the same protein for different animals. The animals which are much more exposed to viral bacterial infections, the same protein in those organisms has higher potency, has improved upon, because they face these infections much more. If you are left to untreated from these organisms, some generations will die, but eventually generations will emerge with far more potent innate immune system. But we cannot afford this for mankind. But some animals have gone through this. So just final one or two words, I will just skip some of the things, but show you what is the difference. When you look at the same protein from 3 different animals, camel, porcine, and human representing all other animals. Now, this protein has same structure, but the organizations are different because a very few mutations have occurred. Like you might have heard about virus, that some new strains have appeared. So there are a couple of mutations there. So camel and porcine have introduced some mutations. As a result, camel protein works as a dimer and porcine works as a trimer, human works as a monomer. The trimer is far more potent than monomer. The dimer is far more potent than monomer. So therefore, from these studies, it's clear that a human protein can be modified like that of camel protein and can be introduced as a therapeutic molecule. And it's very simple, that just 2 mutations. And because of that, the proteins have become dimers, and with some more mutation, they have become trimers. So this is how, just to show, if you have a monomer, I'm just finishing, what's the time, right? Time is just 2 minutes. If you have a monomer, how does it, even if you are a student of arts, I will ask at the end from Professor Al-Sadi that how much he got bored on in this presentation. I'll ask him to compare mine with Gyan Prakash's, who has inspired him more or less at the end, not now. So this is a protein. Now you see this cleft kind of thing. That is where it binds to cell wall molecules. Now if it's a monomer, it binds like this. These are cell wall molecules. But if it's the structure of this human and camel protein identical monomers, but camel protein exists as a dimer. So if you have a dimer, then you see large part of when 2 molecules interact, how much they are in contact will determine the affinity towards each other. If you catch something with so much, you will hold this better. So that is the dimerization has enhanced the affinity of camel protein by 10 to the power 3 times than the human and other animal proteins. And that is why camels are protected well. I think I don't want to sort of go on and on, but the gist is that innate immune protein, still people are not at that stage of realizing this. Innate immune proteins of animals, particularly those animals which have been exposed much more to hard microbes, animals living in hostile conditions, in high temperature deserts, in low temperatures, in dirty environments, their protein, they face more overloads of these organisms, bacteria and viruses, so they modify their proteins of innate immune system, the first line of defense, and they protected themselves better. And from this, we learned that we can use these proteins, which are more potent, for the innate immune system, not antibodies, not vaccine. See, vaccines just for one organism, but innate immune system for everything. This is a general kind of defense mechanism. And even centuries and centuries, bacteria and viruses have not developed any resistance to these proteins because they have a general way of grabbing these organisms. So innate immune proteins are the solution to face future endemics, to fight future endemics. And that is what this message is all about. I thank you very much. I don't want to go on and on. If you had started at 10 o'clock, I would have gone on to up to 11 o'clock. But now, since time is running out, it's just I wanted to give a gist. And I think the purpose of science seminar is, this science seminar is to stimulate and inspire people. But I also want to say, I'm countering Professor Hegde, whose fan I am since yesterday, that the funding situation, the funding behavior of agencies is far better than it was before. We see it less because there are more claimants now, there are more applicants. I remember I have been involved in the DST program, how much DST has been thinking of innovative ways to fund universities. There were several new programs started. I have been part of this since the beginning. So these funding procedures were not there before. So, and overall funds to these agencies are increased. So I think the situation is not that way. And eventually, if your economy improves, everything will grow. And I feel that the next period will be for country like ours, because we have the best human resource, and that is the advantage. Thank you so much.
Ladies and gentlemen, when Professor T.P. Singh speaks, we are reminded of the redoubtable professors such as Professor T.H. Huxley of England and Professor Louis Agassiz of Harvard University, where Agassiz founded both geology and zoology. Now, only now we are waking up to the importance of interdisciplinary and multidisciplinary studies. So now I request our Honorable Vice Chancellor, Professor Muzaffar Asadi, to felicitate both Professor T.P. Singh and Professor S.N. Hegde. ದೊಡ್ಡದು ಮಾಡ್ಬೇಕು. I request Honorable Vice Chancellor to felicitate Professor S.N. Hegde. Thank you very much, sirs. Ladies and gentlemen, the function will draw to a close in another 10 to 15 minutes. Kindly bear with us. Professor Muzaffar Asadi, our Honorable Vice Chancellor, holds a postdoctoral degree from the University of Chicago, USA, 1997, PhD from Jawaharlal Nehru University, New Delhi, on agrarian movement in Karnataka, growth, evolution of KRS, 1987. As visiting professor, he has taught at the Russian State University for Humanities in Contemporary Indian Studies, 2014, visiting fellow at Punjab University, 2010, visiting fellow at Kerala University, 2007, was also visiting fellow at Madras University. Professor Asadi is a regular columnist in various dailies, apart from his scholarly articles in peer-reviewed journals. Now, Professor Asadi has won many awards, distinctions, and recognitions for his works. I request our Honorable Vice Chancellor to deliver the presidential speech.
Yeah, good afternoon to everybody. Dignitaries from the dais and the off the dais. Let me begin with the one gift that we gave to Professor S.N. Hegde and T.P. Sen. In fact, one book we have gifted to them, which is printed in my city, and it was located for the first time in the Maestro city. This book is Artha Shastra, Kautilya's Artha Shastra. I've decided that our guest henceforth will get either Poempu's Ramayana Darshanam or Kautilya's Artha Shastra as gift from the University of Mysore. Probably this tradition needs to be continued. But let me look at the whole debate on the science and the well-being. You know, if you look at the thrust areas that have been adopted for the last couple of years, it makes me to think that a couple of debates have been brought in here, which cut across the boundaries of the science. You know that we always feel that the science has created its own boundary. It cannot negotiate with the other things. Like, for example, it cannot negotiate with the social sciences. Look at the issues that they raised. For example, like the issues of the gender as one of their thrust areas earlier. Or take the case of the environmental issues that the Science Day raised it. Which obviously means that there is an attempt to make science as social. So you cannot simply say that science is exclusively science. It has, it has created its own boundary, but rather it has become social. Social in the sense that it is responding to the social needs, social changes, which obviously means that it has also brought in what Kuhn talks about paradigm shift in the social life, in the knowledge system as such. Because ultimately the science has produced a new knowledge system, which is not fixed, which is always changing. Right from the beginning of, take the case of the Newton, up till the latest discovery on the COVID. Science is changing, science is, negotiating with the changes. Science is also bringing paradigm shift. Science is also creating some of the myths. Meanwhile, we need to understand the fact that it is simply science is not a given subject as such, but it has also created a lot of myths. I would say that there are nearly 4 or 5 myths that the science has created. The one myth, if you look at the thrust area itself, global science has created global well-being, which is obviously is a myth. I remember, if you look at that kind of myth, then obviously we can argue that global science has created multiplicity of the knowledge system. That's one thing. It is created the knowledge system. It has, created a hiatus between the indigenous knowledge system, which always tries to suppress it. For example, you might be knowing about the argument that Macaulay made with regard to the Indian knowledge system long back in 1830, when he said that, in the Indian knowledge system, all the Indian knowledge system is equivalent to the one shelf of the British. He was absolutely condemning the Indian knowledge system, whether the contribution of the Sushruta or the contribution of the Aryabhata or the contribution of Zero and other things, including the knowledge of the Ayurveda. Even though it is all secular knowledge system, he tried to marginalize the Indian knowledge system. And that's the reason why, when I think, if I'm right, when the Calcutta Medical Association was established, they were trying to find out the Western medicine for the Indian problem. I think that's the whole thing, entered into a whole debate at the time of plague. If you read Gandhi's experiment in Natal, in Africa, there was a whole debate about, adopting to the Western medicine and using the indigenous variety. One thing was that Gandhi was trying to experiment with the plague-infected people. And this is very much obvious in a lot of literature that Gandhi wrote about in India. And his experimentation started in a garage in the Natal, and he used indigenous method. For example, if you read his book on health, wherein he clearly stated that we require to adopt certain methods to prevent the plague or the pandemic as such. Like, for example, social distancing. It was Gandhi's concept actually. Or using the mud to reduce the fever and other things. And he was using, he was just opposed to the Western medicine and the use of whiskey, remember, intoxication, to the to the patients of the plagues. And incidentally, Gandhi was true. Gandhi, emerged as a victorious using the Western medicine. It was not simply, experimenting with the medicine, but it was creating kind of debate. What kind of, science that you require? Do you require the science, Western science, which believes in the indiscriminate use of the what's called natural resources? Look at, for example, today we might say that climate change is the result of our consumption. In fact, it was also the result of our scientific inventions, for the purpose of, our own making our life most easy. We use these tissue papers, refrigerators, plane, or take the case of the vehicles. All these things, they have increased the temperature of the world, even though a category of middle class must have emerged. But actually, this energy, consumption of energy, which is literally created a leisure life, a leisure category. But at the same time, it has increased the temperature of, globe. There are studies, for example, like the Professor Chandrasekhar's study on, climate change, particularly on the North Karnataka. He said that by 2030, the environmental, impact, the climate change would, increase the temperature of the, that North Karnataka by 0.5%. That would have the cascading effect on the migration of the people. That would have the, cascading effect on the displacement of the people. It might definitely increase the poverty level. And poverty level, if you look at the way the science is created, it has literally created the binary opposition as such. Look at that is a study by, Kathleen Gog, long back. It's about the study on the Green Revolution. Green Revolution is a product of the, science. Norman Borlaug introduced it for the simple reason that would, reduce the hunger. That would reduce the inequality, social inequality. That would also reduce the what is called the social conflict. But what happened actually? A study conducted in the Tanjore definitely said one thing, that the Dalits or the agricultural laborers, one side they were all beaten up for asking for the more wages. On the other hand, the laborers, particularly agricultural laborers, were living on the field rats for living. Remember, you had the prosperity, but at the same time the deprivation. We went together, particularly Green Revolution created. Similarly, is the case of Punjab. Punjab did not solve the problem of the hunger. Today, I think the not less than 2.8 million of populations have been added into our list, saying that this number has increased to the to the level of the poverty, or the poverty below the poverty line. If you look at Indian context, probably 85% of the population are living below the poverty line, despite the fact that the world, FAO says that we have got a plenty of, food. How do you look at this kind of problem? One side, this has created the binary opposition. The science has created the binary opposition. Other hand, it also created the prosperity. And also, it has also created, insecurity, feeling of insecurity. Look at the, nuclear armaments. Couple of days back, Putin, has withdrawn, negotiating with the United States, and probably is also withdrawing from the 123 agreement. That has created the tension. That has created the insecurity in the context of the, the global peace. The whole argument, if you look at the argument which was constructed during the time of the, bombing the Nagasaki and Hiroshima, it was simply one side, it was experimenting on the virgin land and the people. At the same time, it was also backed by certain desire to control the globe. Remember, in one side, this has created the tension. The tension is very, very severe now. At the same time, it also created the notion about dominating the world. Ultimately, in a scientific research, who controls? Has it been able to create these binary oppositions? One binary opposition that I could visualize is the North and the South. The United States and its, Anglo-Saxon countries. They control our knowledge system. Look at the scientific research work that have been done. R&Ds. Indians we are not concerned about more about the R&Ds, but we are concerned about the production, knowledge, intellectual property rights. Who has these intellectual property rights? Science has created the scope for the, control of the intellectual property rights by the West. The West controls, West decides, not the third world or the developing country. In fact, the knowledge system, the science as a knowledge system has created the new world. which is called as the fourth world, which is a highly underdeveloped world. You know, we are in the midst of what's called the binary opposition. Developed, highly advanced, highly prosperous, one side. On the other hand, the science has also created the sense of insecurity, fear, bias, undermining the knowledge system and all these things. Probably the answer for this thing, I don't know where do you locate the answer? Science is wonderful in one sense. Science is also, help us to overcome some of the diseases. Some of the permanent, it has brought this solution for the permanent issues. Like, for example, when it comes to the question of the health issues, like, for example, measles have disappeared. But cancer, whether the cancer has disappeared? Do you have the answer for the HIV? Who are being called as the positive people? They are not being able to answer. What about the COVID? COVID was not simply the creation of the certain countries, but it was also meant to control the market also. Yeah, I know. So in this particular context, we need to rework, revisit the whole issues about the science, global science, and the well-being. I would see the answer in Gandhi. Gandhi would not, allow, or the Gandhi would not say, advocate the, unscrupulous exploitation of the natural resources, but he would rather argue for what is called the common good. With this note, I would express my sincere thanks to given the fact that he has to get the flight in by 7 o'clock, T.P. Singh ji, and also Professor S.N. Hegde, our former Vice Chancellor, was literally supporting the intellectual activities in the University of Mysore. I would like to thank them profusely for coming down to this place and delivering the wonderful lecture. Thank you very much.
Thank you very much, sir, for providing a social sciences perspective on the contemporary reality. We're coming to the end of the program. Madam V.R. Shailaja, our Honorable Registrar, is the alumna of our university. She secured second rank in BA final exams from the University of Mysore during 97-98, bagged 9 gold medals and 7 cash prizes awards in arts faculty for outstanding performance in BA 1999. Secured first rank in BA in 1998-99. Again bagged 2 gold medals and 2 cash prizes, securing first rank in MA Geography, bagging 3 gold medals and 1 cash prize in the 82nd convocation in 2001. Before passing her Karnataka Administrative Service, Madam Shailaja has worked as a teacher for 5 years. As an administrator, she has been Tehsildar, Zonal Commissioner, Assistant Commissioner, and Additional Deputy Commissioner. She brings in all her administrative experience to the field of academia, and as registrar of our 107-year-old university, she's doing an outstanding job. Madam, over to you to propose a vote of thanks.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಬಹಳ ಸುದೀರ್ಘವಾಗಿ ನಡೆದಂತಹ ಕಾರ್ಯಕ್ರಮ. ನಾನು ನನ್ನ ಮಾತನ್ನ 2 ನಿಮಿಷದಲ್ಲಿ ಮುಗಿಸ್ತೇನೆ. ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾಲಯದ ಈ ಒಂದು ಗೌರವಾನ್ವಿತ ಹಿರಿಯರೆಲ್ಲರೂ ಕುಳಿತಿರುವಂತಹ ವೇದಿಕೆಯಲ್ಲಿ ತಮ್ಮ ಸಮ್ಮುಖದಲ್ಲಿ ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನಾಚರಣೆಯನ್ನ ಆಚರಿಸಲಾಗಿದೆ. ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಆಗಮಿಸಿ ನಮ್ಮನ್ನೆಲ್ಲ ಉದ್ದೇಶಿಸಿ ಈ ಕೋವಿಡ್ನ ಅಲೆಗಳ ಸಂದರ್ಭದಲ್ಲಿ ಸೂಕ್ಷ್ಮ ಜೀವಿ ಸೋಂಕುಗಳ ವಿರುದ್ಧ ಸಹಜ ರೋಗ ನಿರೋಧಕ ಪ್ರೋಟೀನ್ಗಳ ಚಿಕಿತ್ಸಾ ಅನ್ವಯಿಕತೆ ಈ ಸಂಬಂಧವಾಗಿ ಬಹಳ ಸುದೀರ್ಘವಾಗಿ ತಮ್ಮ ಸಂಶೋಧನಾತ್ಮಕ ವಿಷಯ ಮಂಡನೆಯನ್ನ ಮಾಡಿದಂತಹ ಶ್ರೀಯುತರು ಪ್ರೊಫೆಸರ್ ಟಿ.ಪಿ. ಸಿಂಗ್ ಸರ್ ಅವರು, ಗೌರವಾನ್ವಿತ ಜೈವಿಕ ತಂತ್ರಜ್ಞಾನ ಸಂಶೋಧನಾ ಪ್ರಾಧ್ಯಾಪಕರು, ಜೀವಭೌತಶಾಸ್ತ್ರ ವಿಭಾಗ, ಅಖಿಲ ಭಾರತೀಯ ವೈದ್ಯಕೀಯ ವಿಜ್ಞಾನ ಸಂಸ್ಥೆ ನವದೆಹಲಿ, ಇವರಿಗೆ ವೈಯಕ್ತಿಕವಾಗಿ ವಿಶ್ವವಿದ್ಯಾನಿಲಯದ ಪರವಾಗಿ ಇಲ್ಲಿ ಹಾಜರಿರುವಂತಹ ಎಲ್ಲ ವೈಜ್ಞಾನಿಕ ಮನಸ್ಸುಗಳ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ವಂದನೆಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ ಸರ್. ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಸರ್. ಅದೇ ರೀತಿಯಾಗಿ ಇವತ್ತಿನ ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನಾಚರಣೆ ತಮ್ಗೆಲ್ಲ ಗೊತ್ತಿರೋ ಹಾಗೆ ಈ ವರ್ಷದ ದ ಥೀಮ್ ಆಫ್ ನ್ಯಾಷನಲ್ ಸೈನ್ಸ್ ಡೇ 2023 ಇಸ್ ಗ್ಲೋಬಲ್ ಸೈನ್ಸ್ ಫಾರ್ ಗ್ಲೋಬಲ್ ವೆಲ್ ಬೀಯಿಂಗ್. ಸೊ ಇದನ್ನ ನಾನು ವಿದ್ಯಾರ್ಥಿ ದಶೆಯಿಂದನೂ ನೋಡ್ಕೊಂಡು ಬಂದಂತಹ ಅವರ ಮಾರ್ಗದರ್ಶನದಲ್ಲಿ ವಿಶ್ವವಿದ್ಯಾಲಯದಲ್ಲಿ ಕಲಿತಂತಹ ವಿದ್ಯಾರ್ಥಿನಿ ಶ್ರೀಯುತರು ಪ್ರೊಫೆಸರ್ SN ಹೆಗ್ಡೆ ಸರ್ ಅವರು, ವಿಶ್ರಾಂತ ಕುಲಪತಿಗಳು ಹಾಗೂ ಮಹಾನ್ ಚೇತನರು ಹಾಗೂ ವಿಜ್ಞಾನಿಗಳು. ಶ್ರೀಯುತರನ್ನ ಈ ವಿಶ್ವವಿದ್ಯಾಲಯದ ಸುದೀರ್ಘ ಗೆಳೆಯ, ಮಾರ್ಗದರ್ಶಕ ಹಾಗೂ ಸಂಶೋಧಕ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಅತಿಶಯೋಕ್ತಿ ಆಗ್ಲಾರದು. ಶ್ರೀಯುತರು ಕೂಡ ಭಾರತದಲ್ಲಿ ಐತಿಹಾಸಿಕವಾಗಿ ವಿಜ್ಞಾನದ ಬೆಳವಣಿಗೆ, ಆಧುನಿಕ ಭಾರತದಲ್ಲಿ ವಿಜ್ಞಾನದ ಬೆಳವಣಿಗೆ, ವಿಶ್ವವಿದ್ಯಾಲಯದ ವತಿಯಿಂದ ವಿಜ್ಞಾನಕ್ಕೆ ಕೊಟ್ಟಂತಹ ವಿಚಾರಗಳನ್ನ ಮಂಡಿಸ್ತಾ ತಮ್ಮ ವಿಚಾರಗಳನ್ನ ಬಹಳ ಸ್ಪಷ್ಟವಾಗಿ ನಮ್ಮೆಲ್ಲರಿಗೂ ಮನದಟ್ಟು ಮಾಡಿಕೊಟ್ಟಿದ್ದಾರೆ. ಅವರಿಗೆ ನಾನು ವೈಯಕ್ತಿಕವಾಗಿ ವಿಶ್ವವಿದ್ಯಾನಿಲಯದ ಪರವಾಗಿ ಹಾಜರಿರುವಂತ ಎಲ್ಲ ಸಭಿಕರ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ವಂದನೆಗಳನ್ನ ಅರ್ಪಿಸ್ತೇನೆ ಸರ್. ಅದೇ ರೀತಿಯಾಗಿ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮದ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ವಹಿಸಿದಂತಹ ಮಾನ್ಯ ಕುಲಪತಿಗಳು ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯ ಪ್ರೊಫೆಸರ್ ಮುಜಫರ್ ಅಸಾದಿ ಸರ್ ಅವರು ಆಧುನಿಕ ವಿಶ್ವವನ್ನ ವಿಜ್ಞಾನ ಹೇಗೆ ಚಿತ್ರೀಕರಿಸಿದೆ, ವಿಭೇದಿಸಿದೆ ಅನ್ನೋ ವಿಚಾರಗಳನ್ನ ಕೂಡ ಹೇಳಿದ್ರು. ಈ ರೀತಿಯಾಗಿ ತಮ್ಮ ಮಾನವಿಕ ಮೌಲ್ಯಗಳ ಮೂಲಕ ವಿಜ್ಞಾನವನ್ನ ನೋಡುವ ದೃಷ್ಟಿಕೋನವನ್ನ ನಮ್ಮೆಲ್ಲರಿಗೂ ಅವರು ಇವತ್ತು ವಿಚಾರವನ್ನ ಮಂಡಿಸಿ ನಮ್ಮೆಲ್ಲರಿಗೂ ಮಾರ್ಗದರ್ಶಿಯಾಗಿ ಮಾತನಾಡಿದ್ದಾರೆ. ಶ್ರೀಯುತರಿಗೂ ಕೂಡ ವೈಯಕ್ತಿಕವಾಗಿ ವೇದಿಕೆಯ ಪರವಾಗಿ ಹಾಗೂ ವಿಶ್ವವಿದ್ಯಾನಿಲಯದ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕ ಧನ್ಯವಾದಗಳನ್ನ ಅರ್ಪಿಸ್ತೇನೆ. ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮದ ಪ್ರಾಸ್ತಾವಿಕ ನುಡಿಯನ್ನ ನುಡಿದಂತಹ ಹಾಗೂ ಈ ಕಾರ್ಯಕ್ರಮವನ್ನ ಸಂಪೂರ್ಣವಾಗಿ ಸುಮಾರು ತಿಂಗಳಿಂದ ಬೆನ್ನತ್ತಿ ಕಾರ್ಯಕ್ರಮ ಬಹಳ ಅಚ್ಚುಕಟ್ಟಾಗಿ ನೆರವೇರಲಿಕ್ಕೆ ಕಾರಣೀಭೂತರಾದಂತಹ ಹಾಗೂ ಘನ ಉಪಸ್ಥಿತಿಯನ್ನ ನೀಡ್ತಾ ಇರುವಂತಹ ಪ್ರೊಫೆಸರ್ HT ಬಸವರಾಜಪ್ಪ ಸರ್ ಅವರು, ಡೀನರು, ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ನಿಕಾಯ, ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯ, ಇವರಿಗೂ ನಾನು ತಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ಧನ್ಯವಾದಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ. ಅದೇ ರೀತಿಯಾಗಿ ನಮ್ಮ ರಿಜಿಸ್ಟ್ರಾರ್ ಇವ್ಯಾಲ್ಯೂಯೇಷನ್ ರವರಾದಂತಹ ಪ್ರೊಫೆಸರ್ ಜ್ಞಾನಪ್ರಕಾಶ ರವರು ಕೂಡ ವೇದಿಕೆಯಲ್ಲಿದ್ದಾರೆ. ವಿಜ್ಞಾನ ದಿನಾಚರಣೆಯ ಐತಿಹಾಸಿಕ ಮಹತ್ವ ಮತ್ತು ರಾಮನ್ ಎಫೆಕ್ಟ್ ಹಾಗೂ ಶ್ರೀಯುತ ಸಿ.ವಿ. ರಾಮನ್ ರವರ ಕೊಡುಗೆ ನಂತರ ಆದಂತಹ ವಿಜ್ಞಾನದ ಪಲ್ಲಟಗಳ ಬಗ್ಗೆ ಬಹಳವಾಗಿ ಬೆಳಕನ್ನು ಚೆಲ್ಲಿದ್ದಾರೆ. ಅವರಿಗೂ ಕೂಡ ನಾನು ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ಧನ್ಯವಾದಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ. ಶ್ರೀಮತಿ ಸಂಗೀತಾ ಗಜಾನನ್ ಭಟ್, ನಮ್ಮ ಹಣಕಾಸು ಅಧಿಕಾರಿಗಳು, ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯ, ಅವರಿಗೂ ಕೂಡ ನಾನು ನಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ಧನ್ಯವಾದಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ. ಹಾಜರಿರುವಂತಹ ಎಲ್ಲ ನಿಕಾಯದ ಡೀನರು, ಎಲ್ಲ ವಿಭಾಗಗಳ ಅಧ್ಯಕ್ಷರು, ಎಲ್ಲ ಹಿರಿಯ ಪ್ರಾಧ್ಯಾಪಕರು, ಸಂಶೋಧನಾ ವಿದ್ಯಾರ್ಥಿಗಳು, ದಯವಿಟ್ಟು ಕ್ಷಮಿಸಿ. ಪ್ರೊಫೆಸರ್ ರಂಗಪ್ಪ ಸರ್ ಅವರು ಬೆಳಗಿನಿಂದನೂ ಕೂಡ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಹಾಜರಿದ್ದಾರೆ. ನಮ್ಮ ವಿಶ್ವವಿದ್ಯಾಲಯ ಕಂಡಂತ ಅಭೂತಪೂರ್ವ ವಿಜ್ಞಾನಿಯವರು, ಜೊತೆಗೆ ವಿಶ್ವವಿದ್ಯಾಲಯವನ್ನ ಅತ್ಯುನ್ನತ ಮಟ್ಟಕ್ಕೆ ಬೆಳೆಸಿದಂತಹ ಒಬ್ಬ ವಿಶ್ರಾಂತ ಕುಲಪತಿಗಳು, ಅವರಿಗೂ ಕೂಡ ನಮ್ಮ ನಿಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ಧನ್ಯವಾದಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ. ಇಲ್ಲಿ ಹಾಜರಿರುವಂತಹ ಸಂಶೋಧನಾ ವಿದ್ಯಾರ್ಥಿಗಳು, ಕೆಲವೊಬ್ರು ಬಹಳ ಇಷ್ಟಪಟ್ಟು ಕುಳಿತು ಬೆಳಗಿನಿಂದನೂ ಕಾರ್ಯಕ್ರಮವನ್ನು ಕೇಳದಂತಹ ನಮ್ಮ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಕೆಲವೊಬ್ಬರನ್ನ ಬಹಳ ನಮ್ಮವರು ತಡೆದು ಕೂರಿಸಿ ನಿಮ್ ಕಿವಿ ಮೇಲೆ ಬೀಳಿ ವಿಚಾರಗಳು, ಇಂತಹ ಮಹಾನ್ ವೈಜ್ಞಾನಿಕ ಸಂಶೋಧಕರು, ವಿಜ್ಞಾನಿಗಳು ಪ್ರತಿ ದಿವಸವೂ ಸಿಗೋದಿಲ್ಲ ಮಕ್ಕಳೇ. ಹಾಗಾಗಿ ಸಂಶೋಧನಾ ವಿದ್ಯಾರ್ಥಿಗಳು ಮತ್ತು ವಿದ್ಯಾರ್ಥಿಗಳು, ಅವರ ಸಂಬಂಧಪಟ್ಟಂತ ಎಲ್ಲ ಗುರುವರ್ಯದ ವೃಂದದವರು ತಾವು ಇಲ್ಲಿ ಹಾಜರಿದ್ದೀರಾ. ತಮ್ಮೆಲ್ಲರಿಗೂ ಕೂಡ ವೈಯಕ್ತಿಕವಾಗಿ ಹಾಗೂ ವಿಶ್ವವಿದ್ಯಾಲಯದ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ಧನ್ಯವಾದಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ. ಈ ಕಾರ್ಯಕ್ರಮ ನಡೆಯುವಲ್ಲಿ ನಮ್ಮ ಕುಲಪತಿಗಳ ಆಪ್ತ ಶಾಖೆ, ನಮ್ಮ ಆಡಳಿತ ವಿಭಾಗ, ಹಣಕಾಸು ವಿಭಾಗ ಹಾಗೂ ಪರೀಕ್ಷಾಂಗ ವಿಭಾಗದ ಎಲ್ಲ ಅಧಿಕಾರಿಗಳು, ನಮ್ಮ ಇತರೆ ವಿಭಾಗದ ಮುಖ್ಯಸ್ಥರು ಮತ್ತು ನಮ್ಮ ನೌಕರ ಬಂಧುಗಳು ಎಲ್ಲರೂ ಕೂಡ, ಅದು ಡಿ ವರ್ಗದ ನಮ್ಮ ನೌಕರ ಬಂಧುಗಳಿರ್ಬೋದು, ಅಧಿಕಾರಿಗಳಿರ್ಬೋದು, ಡೆಪ್ಯೂಟಿ ರಿಜಿಸ್ಟ್ರಾರ್ಸ್ ಇರ್ಬೋದು, ಎಲ್ಲರದ್ದು ಕೂಡ ಬಹಳ ಸಕ್ರಿಯ ಪಾತ್ರ ಇದೆ. ಅವರೆಲ್ಲರಿಗೂ ಕೂಡ ನಾನು ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ಧನ್ಯವಾದಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ. ಕಾರ್ಯಕ್ರಮವನ್ನ ಸಂಪೂರ್ಣವಾಗಿ ಲೈವ್ ಕಾಸ್ಟ್ ಮಾಡಲಾಗಿದೆ. ICD ವಿಭಾಗದವರ ಮೂಲಕ, ಮಾಧ್ಯಮ ಮಿತ್ರರ ಮೂಲಕ ಇದನ್ನ ಪ್ರಚಾರವನ್ನ ಮಾಡಲಾಗ್ತಾ ಇದೆ. ಮಾಧ್ಯಮ ಮಿತ್ರರಿಗೆ ಮತ್ತು ನಮ್ಮ ICD ವಿಭಾಗದ ಲೈವ್ ಟೆಲಿಕಾಸ್ಟ್ ಮಾಡ್ತಾ ಇರುವಂತಹ ಸಿಬ್ಬಂದಿ ವೃಂದದವರಿಗೆ ನಾನು ಹೃತ್ಪೂರ್ವಕ ಧನ್ಯವಾದಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ. ಇಲ್ಲಿ ಹಾಜರಿರುವಂತಹ ಎಲ್ಲ ಮಹಾನುಭಾವರಿಗೆ ನಾನು ಪರೋಕ್ಷವಾಗಿ ಪ್ರತ್ಯಕ್ಷವಾಗಿ ಈ ಕಾರ್ಯಕ್ರಮ ಸಾಫಲ್ಯತೆಯನ್ನ ಕಂಡುಕೊಳ್ಳುವ ಹಾಗೆ ದುಡಿದಂತ ಎಲ್ಲ ಬಾಂಧವರಿಗೆ ನಾನು ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ಧನ್ಯವಾದಗಳನ್ನ ಅರ್ಪಿಸ್ತಾ ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಮಾನ್ಯ ಕುಲಪತಿಗಳ ಅನುಮೋದನೆ ಮೇರೆಗೆ ಮಂಗಳವನ್ನ ಹಾಡ್ತಾ ಇದ್ದೇವೆ. ತಮ್ಮೆಲ್ಲರಿಗೂ ಶುಭವಾಗ್ಲಿ. ಜೈ ಹಿಂದ್, ಜೈ ಕರ್ನಾಟಕ. ರಾಷ್ಟ್ರಗೀತೆ ಇರುತ್ತೆ, ದಯಮಾಡಿ ಎಲ್ಲರೂ ಎದ್ದು ನಿಲ್ಬೇಕು ಅಂತ ಹೇಳಿ ಕೋರ್ತೇನೆ.
ಜನಗಣಮನ ಅಧಿನಾಯಕ ಜಯ ಹೇ ಭಾರತ ಭಾಗ್ಯ ವಿಧಾತ. ಪಂಜಾಬ ಸಿಂಧು ಗುಜರಾಟ ಮರಾಠ ದ್ರಾವಿಡ ಉತ್ಕಲ ವಂಗ. ವಿಂಧ್ಯ ಹಿಮಾಚಲ ಯಮುನಾ ಗಂಗಾ ಉಚ್ಚಲ ಜಲಧಿ ತರಂಗ. ತವ ಶುಭ ನಾಮೇ ಜಾಗೆ, ತವ ಶುಭ ಆಶಿಷ ಮಾಗೆ. गाहे तव जय गाथा. जनगण मंगलदायक जय हे भारत भाग्य विधाता. जय हे जय हे जय हे जय 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 हे.
ದಯಮಾಡಿ ಅತಿಥಿಗಳು ಸಭಾಂಗಣದಿಂದ ನಿರ್ಗಮಿಸೋದಕ್ಕೆ ಅವಕಾಶ ಮಾಡಿಕೊಡ್ಬೇಕು ಅಂತ ಸಭಿಕರಲ್ಲಿ ಪ್ರಾರ್ಥನೆ.
ಪ್ರೊಫೆಸರ್ ನಾಗಣ್ಣ ಸರ್ ಅವರಿಗೆ ನನ್ನ ಹೃದಯ ತುಂಬಿದ ಧನ್ಯವಾದಗಳು. ಇವತ್ತು ನಾವೀಗೆಲ್ಲ ಮಾತಾಡ್ತೀವಿ, ವಿಚಾರವನ್ನ ಗ್ರಹಿಸ್ಕೊಳ್ತೀವಿ, ಮೂಲಭೂತವಾಗಿ ಮಾಹಿತಿಯನ್ನ ಸೃಜಿಸಿ ನಮ್ಮೆದುರಿಗೆ ತಂದಿಡುವಂಥದ್ದು ಪ್ರೊಫೆಸರ್ ನಾಗಣ್ಣ ಸರ್ ಅವ್ರದ್ದು.